Hello, everyone, and welcome to the third edition, to the third day of Dev Talks on the QA and testing track. Thank you very much to the organizer, to the sponsors, and in particularly to London Stock Exchange for being our partners for the QA and testing track today. With me, I have Mihai Tudor, the head of software development at London Stock Exchange. I'd like you to join me in welcoming him and listen to the motivating words that he has to say to start the track today. Hello, Mihai.
Hey, good morning, everyone. Thank you for the introduction. Good morning. I'm very happy to be here for the second time at Dev Talks on behalf of the London Stock Exchange. This time, it's my privilege to open the QA and testing day. QA and testing has always been very close to my heart. So it's again a privilege to get to open the day, and I look forward to hearing the amazing line of the speakers that we have planned for today. It's also great to see that how we've all adjusted to the new ways of working. I know it's been hard for everyone. So congratulations to the organizer for pulling this off. It's a very good opportunity for us to meet people within the industry, particularly now during this moment. So my name is Mihai Tudor. I'm with the London Stock Exchange group. So I'll start off by telling you a little bit about who we are and what we do, particularly here in Romania. So the London Stock Exchange is a very old organization, a few hundred years, in fact. That is primarily known for their capital markets business with their trading venues, London Stock Exchange, the Milan Stock Exchange, Borsa Italiana. But there's a lot more to it as an organization than just the capital markets. So for once, we have the post-trade business with the London Clearing House, which is part of the group, which has been tremendously successful over the last several years. We have the index management with FTSE. It's also owned by the group. And last but not least is the group that I'm part of, which is Group Technology, which builds the software that the entire group services are running on, but also selling that software to the third-party customers out there. And I think that's a very important thing to say, particularly for us as technologists, because we get to experiment, we get to be out there with the very best and compete, and take those learnings back, embedded into our technology, so that the group customers, the internal customers can benefit. In Romania, London Stock Exchange Group came and opened their technology hub back in 2018. So I came in 2019, very shortly after that. And we're happy to say that at the moment we have over 230 engineers employed. They're doing a numerous things across multiple disciplines like technology services, software development, testing, application support, infrastructure. We have the data management with the indexes, FTSE Russell, and we have the corporate services with a strong group of project management. And other corporates like HR and others. So I'm very happy to be here. I'll speak a bit about Group Technology that I'm very proud of, and a bit about how we've managed to cope with these uncertain times and with the COVID-19 situation. So it's been there's been very intense efforts that were pulled off by the group and also by the Bucharest leadership, aimed at taking care of our employees, taking care of their health, not only physical but mentally and emotionally as well. So there's a number of programs that have been rolled out over the last couple of months that basically were set out to create the environment and give us everything that we need to do what we do best as technologists, and that is building successful products. There's a number of other initiatives that I'll just quickly mention. 2019 was particularly important for Group Technology, so we had a cloud initiative. So last year we had our first cloud deployment for our exchange, the trading system. So we have a cryptocurrency running in cloud as of last year. There's a tremendous effort into that, and it's a tremendous achievement. We have a new product suite for our post-trade, which has been very successful, particularly in this recent volatility. And we have a number of ambitious efficiency improvement programs that we're rolling out. And that leads us to quality, and what do we do to support that? I mean, obviously, quality is very close to. We take quality very serious as being a regulated market, and we have a obligation and a responsibility for our customers and for the market out there to provide them with reliable products. So this is something that we take very seriously. I've seen recently a report, particularly built for the open source community, out there, saying that, among other things, stating that programmers use up to and more than 50% of their time doing testing. And I think it got the industry divided on, I don't know whether that's a good thing or a bad thing. There's people saying, well, that's an anomaly and needs to be fixed. And there's other people saying that this is what we expect people to do, and if not, encourage that thing. So, I mean, there's always a question, particularly coming from the senior leaders, that what can we actually do for testing, for testers? How can we build our organization as a test driven organization? So I'll tell you a story very quickly that I used to answer that question. It goes back when I was a child. So I used to play football for my local team. I was not particularly good at football, but I was a very good runner, so that got me on the team. And I remember that there was no second-class citizens in the team, right? So everyone was a first-class citizen. And I also remember my coach, who's to this day one of the best leaders I've met, simply because he managed to describe in a very clear and unambiguous way what success looks like, right? So every time we go onto the court, he used to tell us, well, go there and score more goals than you take, right? So if you look at a goalkeeper, right, there's no goalkeeper out there that think of himself or herself as a second-class citizen, right? Why? Because simply, it's not because they don't get to score, right? It's because they contribute to the victory by keeping the other team from scoring. Now, when I was not playing for my club team, I used to play football in the school's backyard. And in there was a totally different scenario, right? In there was no objective alignment. Everyone had their own perception of victory. And back then, if you were asked to play the goalkeeper, you're probably the worst player in the team. You knew that. Everyone else knew that. And that's how the things were. And I traced it back to the definition of victory, right, of success. When we were playing in the school's backyard, success was not about winning the game. It was about having fun. It was about hitting the ball. It was about running. And obviously, the goalkeeper was doing less of that, right? So the point here is that even the slightest change in the definition of victory has a tremendous impact on how important certain roles are, right? So you have the same game with the same rules. You change a little bit how victory or the alignment of your organization, and people start making their own success stories and concentrate on what they personally think is the best, and that's always in line with the organization, right? So, bottom line, if as an organization you want to make testing a first-class citizen and build your testing organization as a core practice, you need, as a senior leader, to come up with clear, measurable objective. Something that drives the right behavior, and something that demonstrates and highlights the quality of your software engineers, right? So looking at how do you measure projects, making sure that you measure projects also by the time, the effort spent into building the wrong thing, for example, or the benefit it brings to the next project, and that's where testing and QA contributes the most. So hopefully that's been that's been interesting. I look forward to hearing the speaker for today. I have my colleague Sudeep speaking later today, and he's going to tell you a little bit more about how we approach testing within the organization. And I look forward to the day, and enjoy the rest of the day, and have a nice weekend ahead of you. So thank you, Florin. Back to you.
Thank you. Very, very interesting talk, and very interesting parallel to team sports. I really second that approach. Thanks a lot, Mihai, for your intro talk, and thanks again for sponsoring the Q&A testing track at DevTalks.
Thank you, everyone. Enjoy the day.
For all of our attendees, please don't forget to go into the next session. We will start that in about 5 minutes. So thank you. Hello, everyone. Welcome back to the QA testing track. I hope you had you enjoyed the intro talk. We now have our first speaker. We have Areti Panou. She is the product owner of internal program management tools at SAP, and she will be telling us today about how to turn the quality of your deployment pipeline into a team task. Areti, the stage is all yours.
Thank you. Have a nice day, everyone. Good morning. So I'll share my screen to start off the presentation. And here we go. Probably a presentation with the longest title ever. Today, I want to tell you a story from back 2013 when I was not a product owner, but I was doing quality assurance. I was doing the testing in a very small SAP product that was more or less kind of a DevOps dream even back in 2013. Our code and our tests were in Git. They were versioned. We had a continuous integration running on Jenkins. We had feature toggles. We deployed our code daily to production almost automatically. We were monitoring production. We were doing all the things that would be considered more or less even today DevOps. And to do that, we also had a large number of automated checks in place that were checking functionality of the code. They were checking the performance. They were checking the security. All of that orchestrated in a nice, stable deployment pipeline. And most importantly, we were all happy to take, let's say, responsibility for the quality, both of our code, but of our product. We were a team that we were working very closely together with one another. We liked working with one another. So even though I was doing the quality assurance, more or less everyone was feeling responsible for quality. So what could go wrong? Well, many things did go wrong, of course, as often happens. But what I would like to talk to you about today is about that time that we missed a release to our customers because nobody fixed the API tests that we had in our pipeline that were basically checking the business logic of our application. So it was a Friday morning and the release was planned for Monday. And back then, to release functionality to the customers, not do the deployments, but to release functionality to the customers, we needed to do a big meeting with people from the company where we needed to present reports about the quality, let's say, of the software. So since I was responsible for quality, I was the one collecting all the reports or the test cases that were done, the results of the pipeline, but also manual things that were around quality. So I saw in the morning that the tests were failing, that the pipeline was broken, but I didn't do anything because I was busy doing the reporting. And I also didn't do anything because I thought, okay, these are the API tests. These are the tests, the main business tests. I'm pretty sure somebody will fix them. And I was very busy. I was doing reporting. And around 3 o'clock in the afternoon, a colleague shouted from the other office, okay, who's fixing those tests so that I can push my changes and go home? And then we all realized, we started looking one another and we realized that nobody was fixing those tests. And as people realized that the tests were broken and that the release was on Monday, they all started looking at me and more or less not saying it out loud, but thinking, how could you let this happen? Started fixing the tests. It was not as easy as one had expected. Long story short, we missed the release. And let's just say it was not a very good environment in the office for the next week. We missed the release. We didn't put our changes through. But after some time, when we let things calm down and say, okay, we started figuring out what happened. And what we realized that each of the team members realized that they were not sure whether they were the ones that caused the failure. And even more importantly, they were not sure whether they were the ones that should be fixing the failure. And what we all came to the conclusion is that unless I went to them and said, you need to fix the tests, people were not taking the initiative to do it on their own. They were not sure. We were all responsible for the quality of the pipeline, but I was the trigger for action to take place. We all saw the problem, but nobody took the initiative to fix it. Now, unsurprisingly, there is a psychological phenomenon that explains such kind of behavior, and that's called the bystander effect. The bystander effect is the phenomenon in which individuals are less likely to offer help to a victim when other people are present. The greater the number of bystanders, the less likely it is that you will be the one helping the victim. Because being surrounded by bystanders gives you this ability to hide in the ground and say, oh, this is not my thing to fix. Now, I'm not good at psychology. I have very limited knowledge about it. But what I do know more about is pop culture. And there's a reference to the bystander effect in pop culture. In Douglas Adams' Life, the Universe and Everything, which is part of the Hitchhiker's Guide to the Galaxy trilogy of 5. And that references the somebody else's problem field. And what that field does, it relies on people's natural predisposition not to see anything they don't want to, weren't expecting, or can't explain. What this field does, this invisible field does, is you hide something in plain sight by making it somebody else's problem. If it's somebody else's problem, you don't see it. This is what the magic of this field. And such a field was covering our pipeline too. The failing steps were always somebody else's problem because we didn't want to see them, we didn't expect to see them, or we couldn't explain them. And this is precisely what this presentation is about, how to address this somebody else's problem field if you have one over your pipeline. This is an SCP field, it's not an SAP field like my company. So during the talk I will say SCP maybe a lot, and it's not SAP. The things that we will look into, it's what sets off this mentality. So how is this field activated? What are the reasons? What are the events that maintain such a field over the pipeline? Why don't we want to fix things? And how can we address such reasons and events? And the final thing is that how can we remove the field and how to keep it inactive? Because even if we say, okay, I have taken measures, how do we try to ensure, the best we can do is try, that it doesn't come back over our pipelines? And to me, at least, this whole thing starts with let's say, the mentality or the truth in Agile that we say, in an Agile team, everyone's responsible for quality. But what this thing does, it leaves a gap in the personal responsibility that each one of us has for quality. I'm responsible for quality, but what am I supposed to do? And usually that gap was filled by QAs acting as messenger boys, or in my case, as a messenger girl. Oops. So historically, as testers or as people responsible for quality, what we did is that we would inform developers about errors, about failures, about things that were not going well. And as technology changed and many of the tests got into the pipelines, many of the checks went into the pipelines, we took over that role of informing that something is wrong with the pipeline. So as a tester, whenever I saw that the step was broken, and especially if that step that was broken contained some kind of functional tests, I would be the one informing the developers to go have a look. I would inform about the severity. I would inform about when this thing needed to be fixed. And if I saw that there was inaction, I would also be the one saying, oh, maybe now it's the time to have a look at that thing that is failing. And I did that not only because I thought that was an expectation of my role, but I also did it because I didn't trust developers. I didn't trust developers to take action in time. I thought that, oh, whoa, they don't understand that this needs to be fixed now, so I better tell them. And I became somehow the safety net that things went smoothly, but that also turned me and my role as the bottleneck of things. If I'm not there, things just stopped happening. So what was the outcome of that? Developers became bystanders to failures. Whenever they saw a step that was failing, if I would not go there to tell them to fix it, they would think this is somebody else's problem. And this is how this somebody else's problem field got activated over our pipelines. But the thing is that if fixing those broken steps, these things that were failing, was something nice and easy and fun to do, people might have done it anyway. They wouldn't expect somebody to go and tell them. If it was something easy to fix, they say, okay, that will take me 5 minutes, I fixed it. There were reasons that people avoided addressing the issues. So when we realized that, okay, we have this situation, we have this field over our pipeline, the first thing we did is to say, let's start cleaning up our pipeline. Let's improve the quality of the pipeline. And back then there was no Marie Kondo of keeping the things that only that spark joy, but this is what we tried to do. We tried to make our pipeline, to bring it in a state that really sparks joy. And we started with things we didn't want to see, like, for example, flaky steps. And that in 95% of the cases are some sorts of end-to-end tests, checking from the UI to the database. Most of the time there are these kinds of tests, let's be honest. And these are the things that are not breaking because a change detected an issue, but they break just because they feel like it. And when people were asked to fix such things that they didn't want to see, they thought, this thing is a staple, my change didn't cause the error, so I'm not going to do anything about it. And then we thought, okay, what can we do about it? And we took Martin Fowler's advice. We quarantined the flaky tests, not for a long period of time, but we took out the things that were flaky and started examining them one by one. And then we started asking, is this a test that really brings value to the quality of our product? Is this that, can we live without this test? If yes, then we need to find ways to test this thing without having it flaky. If there is something that we can live without, maybe we need to delete it. So we started cleaning up the flaky steps. We quarantined them and tried to stabilize them or remove them. The other steps that people usually don't feel like they don't want to see in front of them are the ones that are running for a long, long time. So you do a change, you break a step, and then you think, oh my God, if I fix this, then I will have to wait for another 2 hours to see the results. This is another category that tends to be ignored. So in this case, we try to see, can we break this long-running thing in smaller steps? Can we run it in parallel? Can we, can we remove some of it so that it's shorter? But mostly it went to parallelizing the checks. And then the third category of things that people usually don't want to see and then don't start fixing are things that are too complicated to fix. For example, you do a change in your code and then you break, 5, 6 steps along the way, and you know that your change to change the code, to change the functionality took 5 minutes, but to fix the entire thing, the entire steps that are in the way takes 3 hours. This is a quote from Sarah Wells. She's at the Financial Times technical director for operations and reliability. And this is from one of her presentations, said a 30-minute code change took 2 weeks to get the acceptance tests working. Now, such kind of things, people are not eager to start fixing. So what did they do? They introduced synthetic monitoring. This replaced our acceptance test. Synthetic monitoring is basically is doing testing on production. Maybe granted, when I first saw this, that they got rid of their acceptance tests and started testing only on production, let's say my gut feeling as a tester was, oh, wow, what are they doing? But when I first started thinking about it, what was the point of having some checks in their pipeline before pushing to production that nobody was fixing anyway? This was just a bottleneck. And I'm not advocating get rid of all the checks you do before pushing to production, but if there are things that are just too complicated to fix and you can check directly on production very fast, maybe that's the way to go. Again, don't get me wrong, I'm not advocating get rid of all the checks you do before you push to production, but whatever is in the pipeline needs to be either simplified or replaced with something different. Now, these were the things that people don't want to see, but there are also things that you don't expect to see happening. For example, what if some of the external services you use for your pipeline are not responding? Let's say that there is a failure because some Nexus repository is not responding. The reaction of most people is that this is such a big failure that definitely there's somebody else trying to fix this issue. This is really big. So what we wanted to do in my team, but we never really got to it, is to ping these external services even before starting the pipeline. Because we thought, okay, what's the point of starting this whole process if we know that somewhere down the line, some of the external services we're using is not there? We never really got to implement that, but that would have been a nice thing to have. We thought about it, but we never actually did it. And so far I've only talked about things that are more or less technical things that stand of the way of you fixing the issues. But there are also some kind of cultural things. For example, what if your change breaks a step in your pipeline that you have never seen before? You don't know about it. You say, oh, phew, by the time I realize what this thing does, I'm not going to start now. This is not my problem. For that one, a good idea is whenever you have a new step introduced into your pipeline, to make a connection with a small ritual to it. One thing that we like doing was name the new step. We had a little competition. Okay, there's a new step. Let's all find a name for it. The best name, the guy or the girl who gives the best name for it gets a sticker. Because if you make a big fuss out of something new, then let's say when you don't see it as something unexpected when it's broken. You adhere a small ritual to it, and then the connection that something new is there is more easy to absorb. And what is also very common, what we saw very common, is that you do a change, you get a notification that your change caused, let's say, an issue, but you and 10 other, 15 other people are in this mailing list of notifications. So if your name is one of the 15 names inside, you say, oh, definitely not my problem. One of the other 15 people is going to fix it. That was a tricky one. We went for using the Claim plugin. That's a Jenkins plugin. And there, at least, we could provide some kind of visibility who is taking care of a broken issue. We would see which things are handled by somebody, and we could see which things are not taking care of anyone. That gave a bit of visibility, and that removed this kind of sense that, oh, is it me? Well, definitely not me. And that was a good starting point. But now there are more fancy tools that could be done, but back in 2013, that worked pretty okay. The main idea was to create some public awareness of who is going to address the issue. And that's all what we wanted to achieve. And the last category of events that maintain this somebody else's problem field over a pipeline were the things that you can't explain. So, for example, steps that their purpose is not clear. If you do a change and you do break something, if you don't understand why that something is there and why is it important and what is it good for, the tendency we have as humans is to ignore it. If it's not important to us, we tend to ignore it. And I can give you here a very good example of things that don't make any sense. This is my work, project test backend scripts dev. I named that step. That's a Jenkins job that tests backend scripts dev. I think besides me, nobody else knew what that thing was testing, doing. Thankfully, that thing was not broken very often. But if it did, for somebody to go and read this and say, yeah, I broke the scripts of what? This is not a good example of how things need to be named or transfer the meaning of what they do. So the more clarity there is in the description, the easier it is to get people to get involved and start fixing them. Other reason that things that you can't explain is steps that you don't know exactly what it means, that how important it is that they're broken. I mean, it is important that always your pipeline is, let's say, green, that it's always runs through. But not all steps are made equal. Not the severity of each step is made equal. If you have steps in your pipeline, let's say, that do some integrations checks, they might not be as severe as, let's say, if you have steps in your pipeline that are checking, do I have open source licenses inside? And do these licenses, open source components, and with licenses that would make my commercial product be open source as well. So even if you have one single failure there, you're not supposed to ignore it. I think your manager will not be happy if your software goes from commercial to open source. These are the things that you can't just put and ignore and get rid of. So to understand the importance of its step and the severity it has to your product and to your business, that's also something that could be clarified, because it is good to know the impact of the step that is in place. And the other things we can't explain is by when do I need to do the fix? Okay, do I need to do it right away? These are some nightly jobs that are running, some nightly steps. Do I need to fix them now? And that usually leaves us of doing things in the last minute and whatever we consider to be last minute. So if we can't explain by when we need to do it, I'm a procrastinator myself, we kind of tend to leave it for the last minute. So here what we did is we gave a fixed time schedule. We said that if something is broken, we have 15 minutes to fix it. And that 15 minutes was applied to all the steps we had in the pipeline because it was easy to remember. We didn't want to have different time frames from different steps. And 15 minutes was a random time number that we gave. And we said, okay, if something could not be fixed within 15 minutes, then just that is a bigger change, that's something more to consider than just reverse the commit and start all over again. But having this stable time frame that you know that this is by when I need to do my fix really helped us not have our pipeline broken. So to summarize this category of how do you know what to do so that you get rid of this can't explain things. On the left, you have a description, just something of your steps like security tests, checks the API. But instead of that, try to put in as much information that is relevant for your business to get a fast solution if they go wrong. So improve the name if you can, improve the description, say when this thing runs, how severe it is to whom, what is the threshold, so what is the implication, what is the threshold, what do I need to take care of. If there are extra informations of how can I fix issues if this step is broken, add a link to a wiki where you have your information, and if there are people that can help when you need to fix something, add their contact, add their time zones, add more in general, add more information to the step. So if it's broken, it's easier for the issue to be addressed so that the situation that cannot be explained what this thing is and what it does gets better. So now we have seen things that we don't want to see, we don't expect to see, or we can't explain what these things might be, like flaky tests, things that run too long, things that you don't know what they're doing. These are some of the things that I have seen in my job back in 2013. But before I became a product owner, I was doing quality coaching in the company. And these were things that we saw happening frequently in other teams as well, not only in ours. And I'm pretty sure that if I would ask any of you now, it would be complicated online, but if I would ask you, do you also have such things? I'm pretty sure you can add more to these categories than these 9 ones that I pointed out. This somebody else's problem fill over our pipeline is pretty pervasive. So now we try to pinpoint these things and try to find solutions for them. But does this mean that the field is gone over pipelines? Yeah, it looks like we're working on it. But now who takes care of things if a failure takes place? Should it be me? And this is the question we still have not answered. Even if the field is gone, even if you have cleaned up everything, should it be you who should take care of the failures? And the question for the answer to that is there needs to be somebody who's automatically assigned to a failure. And that assignment should be done using deterministic rule. For our team, for example, the deterministic rule was whoever causes the failure of a step, that person should be the one fixing it. That was a clear rule that it made sense to us. Other teams might have other rules. For example, say a specific person per week is fixing every step failure. But it needs to be automatically, it needs to be muscle memory in the team to say, oh, there's a step failure. This is the person, I know that this person is taking care of the issue. And the person themselves, they know that I am the one responsible for taking care of the issue. That removes this ambiguity of should it be me, should it not be me, maybe it's somebody else. But having a deterministic rule helps you know that you're responsible for taking care of an issue or somebody else in your team is. But just because somebody is responsible for taking care of an issue, that doesn't mean that that person is all alone in fixing the issue. This is the part where everybody's responsible for quality comes in. If the pipeline is broken, this is everyone's responsibility, not just the person who's the owner of fixing the issue. And this is also very important. This is not about blame. This is about having somebody responsible to take the initiative to bring people together and check together what can be done to get rid of the problem. It might be that they reassign it to somebody else because they will have a solution faster. They might be that they call that some person in and say together, can we sit down and can we see what we both can do so that this issue doesn't happen again? If it's an instability in the step, can we remove it? Do we really need this step? Can we remove it? Can we improve the step so that it stays stable? Let's work on that. Do we have anything that we can do to not have the situation again? This is collaborative work. So whoever's the owner is not necessarily the one fixing the issue. It's just the one driving the changes. And it's a good idea, at least in the beginning, when you start your efforts in changing, to assign a person who would take care of the quality of the overall pipeline. And now with the QAs and testers not having the responsibility, informing people, now that you have a deterministic rule, who knows who takes care of issues, the tester and QA can take care of the role of monitoring the overall quality of the pipeline. Identifying these issues that we don't want to see, don't expect to see, or we can't explain. An example from my experience is that I saw that when a specific step was failing, there were some behavior-driven some Cucumber specifications that were breaking very often. And whenever there was something breaking, all the people would ask a specific colleague to help. So whoever started doing the fix, they would always call that person to help. So what I did is that I sat them all together. That person, that colleague, gave a nice presentation of how this test, these specifications work, how to fix them if there is an issue, where to look at in the code, and what to do. So after that, we saw a reduction of let's say, interactions when something needed to be fixed. That was something I was doing. I was monitoring where things could be improved in our pipeline, and I would start helping people take action. Another thing that, let's say, as a queen of monitoring the pipeline, was to help people understand what actions they needed to take to provoke change. If there was always a false positive, who do they need to address to change that situation? Who was it somebody in our team? Was it someone in the company? To set out a clear path so that they know what kind of action they needed to take when something was not right. But if you're the one having this quality overall role of monitoring, please keep in mind that this role comes with an expiration date. The point is not for people in testing or quality not to be the bottlenecks anymore by telling people that something needs to be fixed and make them now the bottleneck of never improving the pipeline. Part of the role of being the owner of the quality of the pipeline is to educate the team to be able to identify things they don't want to see, don't expect, or can't explain. What are the things that that could be done in the pipeline? How to trigger them and say, okay, you see that this is not working very well. Is there something we can do? And then people will identify on their own how to improve them. In my example with the behavior-driven specifications, instead of me having to call everyone in a meeting, the idea was to make people pay attention and say, oh, I have already asked my colleague twice to help me in that. Maybe I need to learn a bit more about it. So instead of me organizing with the whole team, to give to people this kind of awareness and say, oh, this has been done now more than once, twice, 3 times I need to go to him. Is there any way that I can improve the situation? Another thing, besides educating the people to identify these things, it might be that we also need to convince them to take action. There might be colleagues that say, this is not my thing, I will not take care of improving anything. That's not my job, that's not my part of the job. And in that case, at least my approach was to always, let's say, bring the pain to them. When I knew that they're fixing something that was too complicated to fix, I will just ask them, oh, this is taking you very long. How long have you been working on that? An hour now, right? Boah, that must be very annoying. What would you do so that this thing doesn't happen to you again? So by bringing the value of improving the pipeline and that it has value for their work experience, usually worked to get people involved and get people to improve things. And some of you might say, yeah, that sounds fantastic. I wish I could do that. But this sounds like something that takes lots of time. And you're absolutely right. This doesn't happen overnight. At least it might not happen overnight. And it takes time and it takes effort. And let's say that we had to learn the hard way that if this quality person is the bottleneck, we had to find out the hard way by missing a release. And my experience was that it would have been better if we were proactive and gradually started changing things. Then what happened to us that we missed a release to finally realize that, oh, something needs to be changed here. But it's something that takes time, and it's something that management needs to be on board, because this is something that changes the mentality and the culture of the whole team. And there might be delays because you get used to a new situation. So this is not only a development effort, but it also needs to be a management and product effort. We want to improve things, but things might be a bit bumpy in the start. And we need to have everyone involved of why we're doing this and what are the benefits that are coming if we go that way. So what do we have in the end? What have we talked so far? Where is the starting point? The starting point is that we noticed that we have delays to fix the failed pipeline steps. We saw that it was not, we did not automatically start fixing the pipeline when something was wrong. We had a look to see how could we improve the steps of the pipeline. We took action to make it easier to fix the issues. Automatically assign somebody to take care of the issues, and then the whole team would swarm around them to help. But we knew who was the owner of the issue to take care of it. We monitored the improvements, see what things are working, what things are not working, can we change them a bit? And then try to enable everyone to become a pipeline quality owner, to identify the issues we didn't want to see, didn't expect, or couldn't explain. And then the outcome of that in the end was that the pipelines were fixed in a reasonable amount of time. Our first problem was that there were delays in fixing the issue. Now, the target we achieved was to fix the issues in a reasonable amount of time. Being responsible for quality doesn't automatically make you take action when you see something is wrong. But if we address the situation and make a plan to resolve it, then you can turn the quality of your deployment pipeline indeed into a team task. Thank you.
Thank you very much, Areti. We have one question for everyone now. It's the Q&A part of the talk, so don't hesitate to address if you have any questions in the Q&A section. So question goes like this: any good tips for assigning someone on failing flaky tests, as they often aren't caused deterministically? Can choices by dice be working?
It could work, but it might have, let's say, unexpected effects. You might, it depends on the team. There might be a team that says, we all agree to that, let's all take the pain. And I think that might work there. But if you have members in the team that says, I am out of this, I never caused any failure in this, then this might be problematic. For us, who's ever changed caused the flaky thing. The flaky thing, that's a bad thing about it. It's flaky. That means that your change has nothing to do with it, yet you broke it. So there is some kind of randomness there that you have to be the one to fix it. I think addressing it as a team, in the end, when everybody feels the pain of saying, I have to fix this thing again, I think it will go to the team to say, we need to take care of this and get rid of it. So it's that's the complicated one, because your change does not cause the issue to happen. It's the step itself that's broken.
Thanks, Areti. Any more questions? Also, if you would like, if Areti will still be online, you can find her and ask questions in the app.
Mm-hmm.
It would seem that we don't have any new questions. Thank you for the talk, Areti. It was very nice, a good view also on, besides how to make quality of the pipeline a team task, also giving us some glimpse of best practices. how to do that. Thanks a lot for the talk. To all the attendees, we have another talk starting in around 10 minutes, so don't hesitate to join the next stage. Thank you.
Thank you. Thank you for having me. Bye-bye.
Bye-bye. Hello, everyone, and welcome back. I hope you enjoyed the previous talk. We have another great speaker now with us. It is my pleasure to welcome Sudeep Chatterjee, Head of Testing and QA at London Stock Exchange. I'd like to take again the opportunity to thank London Stock Exchange for being our partner for the QA and testing track. Sudeep, the digital stage is all yours, and best of luck.
Thank you so much. Thank you. And hello and good morning, everyone. My name is Sudeep Chatterjee. I head the QA and testing function at London Stock Exchange at the capital markets side. We're a large team of engineers who work relentlessly to look at how our products are delivered almost defect-free. We try and keep a very, very high standard of quality. And we are going through a transformation journey of quality engineering ourselves, and something that I've worked quite passionately over many years, and I wanted to share some of those with all of you. Just share the slides. Okay, hope all of you can see it now. Right, so I'll start off with this presentation really by going through what are the key questions. Now, quality engineering means different things to different people. I'm sure in the conferences, the last few days and later today as well, you'll talk a lot about that being talked about in kind of a context from an agile DevOps perspective. It has really been a buzzword, really, if I can say that, but something that has been obviously around for some time. But what I wanted to kind of go through today is kind of take a step back on the first slide and say, okay, so what is quality engineering? What are the real questions? And the question number one that really comes up is, when we talk about quality engineering, is that are quality engineers same as developers, or are they a dedicated role of team members automating the testing of the software developer? So there is an application that needs to be developed, obviously needs to be tested, ideally automated. Where does quality engineering comes in? Who is actually doing it? So have a think back into your own organizations that how will you individually answer this question? And maybe in the Q&A section later on, it'll be good to get some view on that. The second question is quality engineering too narrowly focused on stories and not on business outcomes? So every so often I have seen where there is a pressure, a run to make sure that we have achieved our definition of done. We have completed what's required and what's written in the story. We've looked back on what's been discussed with the product owners as part of the acceptance criteria or the story details itself. But is that it? Is that what quality engineering should be? Is that what quality assurance and testing should be? Should we look at that, or should we look at business outcomes? Now, I'm not saying it doesn't happen. I'm just saying that, again, in your own individual organizations, do think that when you're thinking about quality engineering, or for that matter, quality assurance and testing, are we thinking from a stories, features being done, or actually on business outcomes? And the next question really is, again, about that are quality engineering practices too focused on functional requirements, or do they adequately cover non-functional and RAM, which is a common industry acronym for reliability, availability, and maintainability requirements. The point being that, again, every so often I've seen where, and I think it's also probably industry-wide, we don't really capture our non-functional requirements that well. At least in my experience, I've seen that. And the focus tends to be more on the functional side. And quite naturally, the quality engineering practices kind of steers to that. But should it? Should we actually work with the product owners, work with the stakeholders to filter out the non-functional and the operational requirements at the point of the epic being written, at the point of story getting into a backlog, and then making sure that whatever quality practices we want to put in covers those as well. Okay. So that's all good, but what is the goal, right? So this is obviously the starting point, understanding what are the questions. And then I want to kind of go straight and say, okay, so what is the end goal? Where do we want to reach with this quality engineering? So over here, I will bring in a point from Peter Drucker. Now, obviously, some of you may have heard of him. He's founder of, also known as founder of modern management. Obviously, he was an American management guru. And the point he mentioned about quality is obviously not necessarily in context of software, but can be in context of any organization, is that a quality in a product or service is not what the supplier puts in, it is what the customer gets out and is willing to pay for. So there are many themes in this. So first of all is listen to your customers. What do they think of quality? Now, different organizations work differently, where you have internal customers, you may have external customers. You may be a product organization where you have an internal product team and then the product is shipped out for external clients. Or when working in an organization where your initial stakeholders could be more proxy to the final end business. But the main important point over here is that you have to listen to the customers and what do they think of quality. The people who are actually paying to get this software developed, what is their impression about quality? There is also a challenge that there is a conscious and an unconscious bias which limits listening to customers. And I've seen in my own experience where, because of many reasons, organizational construct where the quality engineers are within the organizational view, expectation that this is someone else's job, not my job, maybe the product owner, the business analyst, the delivery manager, maybe someone from higher pay grade will go and do those discussions, and I do not have that outreach, or it is more comfortable for me locally, regionally, language-wise, whatever. So that could be on the unconscious bias, which is restricting me from listening to the customers. There is also another challenge that sometimes you feel that if we go to a customer and ask for this, the demand and needs may change. And there could be a financial construct that is limiting us from doing this so. There could also be a product delivery pipeline that has been constructed internally within the organization, which is looking after technical debt or technology roadmap. Need a new operating system, or we would want to move to a microservices architecture, or fix some defects that impact some different type of customers. And that might be derailed if we go back to our customers and ask for quality, and that limits some of those conversations. So have a think that is it actually happening in your organization, and how do you want to overcome those. And for me, the main success measure really is on two key metrics. And these are the two key metrics I use to measure quality engineering. I think everything else kind of just feeds into this. And I want to share this with all of you. So the first is cycle time. Some of you who obviously been in the agile world for some time and or been doing Kanban would be familiar with this. But from a quality perspective and being a quality manager, I look at these two very closely. Cycle time is the time difference between story accepted in sprint and released to production. So what that means is that when the team starts working on something that has been asked by the customer, from that point onwards, how much time is it taking for a customer to actually get that? Now, in purest agile way, some may argue that that should really be 2 weeks. You know, a sprint runs for 2 weeks, end of the sprint, you go live. But I'm sure most of you would agree that that doesn't happen in the real world. There's a lot more steps that happens after that. And I talked a bit about non-functional and operational. There is obviously an organizational construct that it might get shipped from an internal organization to an external organization or the client organization, who may then go through another round of testing and checking from their perspective. And before an acceptance and certification is done, before it goes through a change management process, so on and so forth, right? But what is that time? Do you know that? And what is being done to reduce that? And the second is lead time, where a story is requested by a customer and released to production. So if something is being asked by a customer, then how much time is it taking for them to actually receive it? How much time is these requests sitting in the backlog? It's an ever-changing demand. You know, if I, as a customer, want something, I cannot wait for 6 months. My demand will, you know, it's completely going to change. The market changes. So do you understand in your organization how much time the customer is waiting? And is quality, and sometimes it's banded that testing is a bottleneck, but is testing a bottleneck? How are you measuring it? Right. So on this one, I'll just kind of quickly say that when you're thinking about quality, always remember, it is not only about the tools or the technology. It is not about the next shiny tool that's going to be coming in that's going to help things. Of course it will. But there is also a people aspect and there is a process aspect. And without all three together, which becomes an acronym PPT, it is not possible to deliver the right quality. Okay. So the next concept I'm going to quickly touch upon is checking versus testing. Again, some of you may have read about this. So this is quite a popular industry debate about what is checking, what's testing. So the first point there, quality engineering success is generally measured on automation coverage. So people talk about how much testing automation we have done and how quickly are they getting executed. You know, we run overnight, etc. And we use a lot of the DevOps pipeline and try and showcase that. But my point is, are these really the tests to explore, discover, investigate, or are they just automated checks which confirm existing beliefs? And it could be positive beliefs or negative beliefs. So it's not really a happy part, the positive test versus negative test point. But the point being that we know the expected outcome. These are known knowns, which we are then outputting through a machine. But are these really tests? Are they really going in and exploring and discovering new areas where things may go wrong? So the final point on this slide is that when you're building your quality engineering strategy, make sure you're not only thinking from a checking perspective. And there is combinations of scenarios, a combination of tests, combination of time that has been allocated for testing as well. I think they're both important. Right, I'm slightly speeding up. I'm conscious of time as well. So DevOps 2.0 is how I'm kind of constituted this, right? So the reason I say this is we all know that organizations have implemented agile and DevOps practices to shift left testing, to migrate from legacy waterfall methodologies. I think it's quite popular now. I don't think there'll be many organizations who are still doing pure play waterfall. And in some form or other, organizations are either started or it's already happening, where teams are embedded, quality engineers, quality assurance are embedded with varying degree and maturity of automation, maybe. But definitely there is a view that this is required. But in my opinion, we need to sort of move to a next stage now and start thinking about the next stage. Because there are a lot of other things that don't necessarily bring in right now as part of the current construct, in my opinion, right? And the first one is security testing. I don't still see a lot of security testing, and the DevSecOps is something that has been talked about by CISOs and security teams, but it hasn't really filtered through. Maybe it's happening in some organizations, but at least I haven't really seen, except for maybe some initial security static testing, but I haven't really seen a lot of dynamic tests, security testing, or even on pen testing happening during sprints, for example. If it is happening, great. If it is not, then do have a look at that. Obviously, security is going to be a big thing. And I think as testing leaders, testing professionals, or even just software engineers, we all need to be aware about the security requirements. The second area is business acceptance testing. Now, again, like I mentioned about from a cycle time and lead time perspective, it's always thought through that this is something that just happens after sprint. It will need to go through a business acceptance testing stage. Some people may call it a UAT stage, where the actual users will use it possibly as an exploratory stage and do a day in the life of type of scenario, a front-to-back scenario, and make sure it's all working fine. And again, I haven't really seen a lot of that coming into from a DevOps or agile or delivery perspective, which again, industry-wide, it's coined as a biz DevOps, where we're actually bringing the final customer, the business, and their quality requirements within the delivery chain. And then the last one is the most interesting one, and this is the one that I'm most looking forward to, is about predictive testing, about using artificial intelligence and machine learning to understand where can the defects come at the point of building. So I think this is the point where engineering, in my opinion, would really come through. Quality engineering would really come through, where it is actually building softwares, it is actually building programs, which then goes and sits on top of an application program and helps that to predict performance issues, predict leakages, memory leakages, and some of that may be happening, but it's more about also on the functional points or construct, which is not happening right now. Okay. And then the last slide, really, and then I'm happy to take questions. So one question that keeps coming back to me is, Sudeep, how do we do defect management in quality engineering? What is the suggestion there? And my answer is simple. We don't do defect management. We do defect prevention. I think if the organization is constantly in the cyclic trap of defect management, it's going to be very hard to move and do a transformation journey to quality engineering. So how do we get there? So first of all the backlog defects needs to be treated as features, same level of estimation and prioritization. Point two, and this is a very contentious point, and it'll be, again, good to get some feedback on this, is, in my opinion, we should stop using any defect management system. The target should be to fix the bugs immediately. The problem in using defect management system is it gives a false sense of relief temporarily, almost like a to-do list, which completely, it completely fills up, and then there's another list that we need to create, etc. Right? The question that needs to be asked at any point is the value of the bug more than the current work being done in the current sprint? And if that is true, then we prioritize that over a current piece of work being done. If the value of the bug, okay, so we type with this, less than the current work being done, then it's a backlog item and needs to be, again, have the same estimation and prioritization with any other feature. So at any point, we are not really talking what's a defect. It is taken at the same level as any feature that needs to be done. And this will help stop the technical debt, particularly on low priority issues, which starts to balloon up very quickly. And then over a period of time, it starts to not just impact the product, but also the team's morale. And lastly, what I recommend very strongly is that in your team, you agree on one defect prevention idea and start implementing it now and see the benefit it brings in. With that, I'll stop sharing and take any questions.
Don't forget, thank you, Sudeep. Don't hesitate to address any questions in the Q&A panel that we have for the talk. We have one raised. Do we have an example of defect prevention?
Yes, very good question. I think definitely. So there are many examples, right? So I'll talk about a very recent example that we are looking at the moment. So, but before I go there, just one quick point I'll mention is that before any such strategy is adopted, it's always important to measure and monitor. You'll find that in any maturity modeling. So first of all, you go back and have the right data to measure that what are the main themes why we have the defect, right? So when I'm doing, and that's still a work in progress, but when I'm doing that exercise with the team at London Stock Exchange Group, one theme of area that's kind of coming up is that when the code is delivered at different stages in different environments, we find sometimes issues with the package and deployment. And there could be different reasons for it. Different environments have different configurations. It could be a human error. It could be the checkouts and the check-ins have not been done correctly, example, et cetera, et cetera. But the main reason, really, point I wanted to mention that is that is a clear area where we found out that X percentage of all the issues are caused by this theme. And now we are building in a strong action plan, working with different partners from the engineering team to reduce that, and then we can monitor that. And then we can go back to the stakeholders in 3-6 months' time, and hopefully at some point where we stop getting any issues around that, and say, okay, this is one theme where we have now prevented defect. So again, like I said, there could be many examples like those. There are other areas that we have started to just look at around how requirements gets translated to tests, and how do we actually do traceability of that, and are tests correctly discussed and reviewed with the stakeholders at the right time, et cetera, et cetera. But I'm sure every organization will have their own areas why defects happen. I'm sure it'll still continue to happen, but the point is that how do we really do shift left and reduce the cycle time and the lead time because of that. Hope that answers the question.
Thank you, Sudeep. Now they keep on coming. We have time for one more, and without trying to be, I don't know, to take sides, I'll take one which I think addresses a bit of a challenge that a lot of people might have. How can we approach management if they don't see QA as important as it is?
Okay, yes, good question. And obviously, I can only talk from my own perspective, right? I think that challenge is globally, in my opinion, across all different sizes of the organization, etc. And one thing I would say and recommend strongly is that I haven't seen any senior leaders who are not interested in efficiency and cost saving. So if you are able to show the data, if you are able to show the problem statement and the solution, and not just a problem, but the solution, in a construct which shows that there will be effectiveness and efficiency, which will translate to either improve time to market or cost saving, I'm sure you will get people to listen to you. But always make sure that there is enough data to back you. And also, you need your partners in the organization to build a strong business case for anything. So have those conversations with your colleagues, and then go back at the right opportune time with your leaders, and I'm sure that they will listen to you.
So we have, let's say, 1.5 minutes, so let's try one more. Do you have an example of artificial intelligence or machine learning in QA processes?
I think, like I mentioned, right, this is obviously still a fairly new area. I haven't personally seen something that is very, quote unquote, good in sort of a capital market trading perspective. But I will, talk about a few things, right? One is, it's not necessarily true sense artificial intelligence, but I'll probably construct it more under the machine learning aspect, is where from a trading platform perspective, we do have a lot of software programs which does algorithmic trading. And that, there are constructs in that, and there are work being done on that using machine learning to actually look at the various orders that coming in, the type of orders coming in, how the software itself then use the right pricing model, etc. But one example I will say is, which I looked at, which I found actually quite interesting, is where there was quite a simple shopping cart example given, and the AI was creating test case on its own. So I'll stop there.
Thank you. Thank you very much for the talk. It was a very, very interesting talk. It's great to see how testing is having such an important role at London Stock Exchange. Thanks a lot, Sudip, for your talk. If you would like to speak with him more, you can find him in the conference area. I understand you also have a webinar.
Yes, thank you so much. Yes.
Thank you. Don't forget, the rest of you guys will be meeting in around 5 minutes on the next talk. Hello everyone, welcome to our next talk. With me, I have David Pacia. He is the test automation manager at Brainly. He has prepared a very interesting talk for us about risks and challenges for IoT and embedded testing. I'd like you to all join me in welcoming him on the stage. David, the stage is all yours.
Okay, thanks a lot. And let me start from sharing the presentation. And just if you can confirm it's working, and then we can start. Okay, so as you said, my name is David Pacia. That's the pronunciation, but you are quite close, and that's great success, because I've heard so many variants. So my topic is about testing, but in a quite specific context. It's about Internet of Things and embedded testing. So it's becoming more and more popular. However, since I started, it was like 2013, a lot have happened, and it's, I would say, the most rapidly changing environment, the most rapidly changing area in terms of testing. And just let me know, give you a quick introduction. What are the challenges there? What are the risks? And finally, why there is so much fun in testing IoT and embedded. So yeah, my name is David. On a regular basis, I work in Brainly, this educational startup from Poland, from Krakow. So my goal was to leave Krakow and arrive to Bucharest. So I arrived to DevTalks. So that's still really nice. And this time it's online version. Yeah, I work as a test automation manager, but in general, there's a little bit wider position. So I'm responsible for the whole context of quality across the organization. So not just automation, but about quality processes, about quality of product, and about culture quality. But let's start. So that's the slide I probably did a couple of years ago, and not so many changed as I tracked the changes. So if I would ask you what Internet of Things really is, probably I would hear a lot of many definitions, but I really like to draw pictures or to present pictures and GIFs and memes. So that's my favorite definition. So Internet of Things is actually the internet, as you know it on a regular basis, as you use it every day. But for physical devices, so you have physical devices connected in an internet infrastructure. They can communicate between each other, send signals, sharing inputs and outputs, then process the data, and finally make some autonomous decisions. So that's not the real fiction. And probably you know that using smart bands, so kind of gamification, who can make more steps, who run faster, and exactly you have Bluetooth scales, and you can just check your progress in terms of in terms of, like, for example, losing weight. So time to begin. That's when I started. It was 7 years ago. That was my first contact with Internet of Things. Actually, not as a tester even, more as a C++ engineer. And then I switched to testing as a, for me at least, more fascinating area. And after those 7 years, so 2 years ago, I changed the company, and that's how it looked like. So what I see here, it's not a mess. It's everything you need to execute the proper testing for Internet of Things devices. So yeah, when you think about the real devices, it seems quite easy. But when you get deeper, it's not really, because except for like web part or mobile part, that is the user part or customer, you have real device. You have physical device that you need to handle, that you need to test, and that you need to basically take care of. So what are the risks and challenges in that terms? So that's probably what you know very well. DevOps is becoming more and more popular. It's like the trend with Agile and Scrum a couple of years ago. So now everyone do DevOps. I mean, everyone has DevOps position, and it doesn't necessarily mean you practice DevOps as a culture, but still, you want to deliver software faster, you want to deliver software in a shorter increments, and you want to do it continuously. And that's why we have such names like continuous testing, continuous integration, continuous delivery, continuous deployment, and so on. But what is the risk connected with that? Well, at first, we have false positives and false negatives. That's what you probably know very well. And just to not describe it here, because as I said at the beginning, I like the picturesque way. I prefer that one. So the first one is when you get the positive output, but in general, it should be fail. And the second one is totally opposite. Is there any good thing about it? Well, actually, there is, because it's deterministic. So you receive over and over again like just misleading output. So it should be true, but it's false, or it should be false and it's true, but at least it's deterministic. And then you have something that was mentioned during the first talk today. You have flaky tests, and probably you know it very well from web, from the mobile perspective. So what does it mean? Well, it means those tests are not deterministic. So having the same environment, having the same input data, having the same infrastructure, once it can fail and once it can pass. How to deal it with? Well, that's a little bit broader topic, and you have heard a little more during the first presentation. But I will show you from the IoT and embedded perspective, what does it mean? So what are the real flakiness reasons for that? The first one is something I call environmental issues. So everything you cannot so easily influence. Humidity, temperature, daylight, or any obstacles on your way. So the communication is via Bluetooth or Wi-Fi, and then you have simply walls or any other obstacles, and the signal can be decreased, or, and that can be surprising, increased. So that's something you cannot so much influence, but you should have it somewhere in your mind. I can give you a short story from my experience. So we had a problem with self-resetting module or monitors. So every time you touch the notebook, the device, or the screen, it was rebooted. So we spent like 2 months trying to investigate what was wrong and what happened, like where is the problem with software. And the problem was with humidity. Humidity was too low, and like every time you were like that's called electricity discharge. So every time you touch something, it was rebooted, and it was not that easy to find. And the second one is something I called accidental ones. So something that again, you don't really have influence at, but you should have it somewhere in your head. So loose wires or changes in your electricity, or memory leaks and other possible issues. And something I call bad boy. And just to give you an explanation, bad boy is when someone come to you. Now working offline is a little bit better, but working offline is when someone come to your desk and then just by accident touch it or move it or kick it, and then something stops working. So just imagine when you move notebook, not so much things can happen. But when you move the physical device and you have just a simple board without any plastic cover, well, that can be much more problematic. The second risk, and probably I can put it even as the first one, is connected with updates. So we know updates very well. We know how to deliver new software to the users. We know how to deploy new software. And just to quickly summarize, when we talk about web, that's quite quick. So you deploy a new version in a couple of seconds, usually. If there is something wrong, you can quite easily roll it back. You always should have backup if you have it and you detect there is something wrong, you can just make it. Then we have mobile apps, and that's a little bit more problematic because when you release the version with a bug, well, it takes some time to release the new version. You have to pass the review from Google Play or App Store. For App Store, is even a little bit longer, but still, you can quite easily release new version, and then users can just put an update. The third category are desktop applications, and here it can be slightly harder. So sometimes you just need to somehow force the user to make an update. And you may know it's from Windows update. And there was a quite, I think it was a couple months ago, there was a problem with Windows forcing the users to update their system. And that was not very proficient for them. So I think they changed it, and now you need to click that you want to update. So they cannot simply just put an update and you have no idea about it. But still, that's possible. You just need to click and then it's updated. But when you talk about physical devices, about Internet of Things devices, when you put an update and something went wrong, there is a huge chance that the device can be, device can be bricked. So you put a new update and the software is not working very well. And because this update is executed in a wireless way, so via Bluetooth or Wi-Fi, when you, for example, interrupt it in the middle of update, there is a huge chance that the device has partially uploaded software and you just cannot use it any longer. And the only way to fix it is to send this device back to the provider and receive the new one. And that's probably not the best way, not the most satisfying way you want to work with a physical device. So how we can prevent that? I called it safety belt, and OTA, that's the abbreviation from over-the-air update. So as I mentioned, it can be Bluetooth, it can be Wi-Fi. Those are two most popular. The first one is continuous upgrade and downgrade. So that's a part of continuous testing. You just try to update, you just try to downgrade. And the important thing, not just one version, because if you are the user, you go for a holiday and you are out for like a month. Let's imagine you have a long, very comfortable vacations. And then you get back, and during the time, there were 5 new versions. So what happens if you update from your current one to the version that is the new ones, the newest one? Well, you can do it in an iterative way, but it's not very efficient. So you need 5 updates. And usually how it works, you have an update from your current version to the newest one. And you always have to check that compatibility. And not only update, you should check backward compatibility as well. Because if there is something wrong with new one, and you should get back to the previous one, well, it should work as well. The second one is what we know from, for example, new mobile apps updates, so small batches at the beginning, just to aggregate some data and metrics and check if everything works. And the third one, and I called it backdoor solution. So continuous upgrade and downgrade, it can be resolved by simply automation and continuous integration. The only difference between our current world, which means everything is moved to cloud, we cannot do it fully, because if you have physical device, you just cannot use only serverless. You have to store your physical devices somewhere in your lab, and then just work with that, communicate with that. So just have in mind that in terms of Internet of Things, it's not possible to move everything to cloud. Small batches that start, so as I mentioned, it's what we know very well. We can have alpha or beta users, we can have early adopters, or just trusted customers. And you may know the sentence, eat your own dog food. So this dog fooding works perfectly in terms of Internet of Things devices. Just use it, and then probably you can detect a lot during your regular usage. And backdoor solution, so whatever you imagine, whatever you discover to make it more stable, to increase or to decrease the risk connected with brick devices. So manual or wired update, maybe several partitions, or, and that's important, to always make a backup of data, even if you will have a new device from the provider. The third one, it's about scale. So scale really matters. Just imagine you have 10 devices, and then you have 20 devices. And usually it doesn't work like you have twice or two times more connections, two times more signals in the air. Because if we say about communicating peer-to-peer, so communicating each other to each other and sending packages into the air, it's not 2 times, but in that terms, it's 4 times higher. So it's like changing in a like we have square here. The more we have devices, the more we have connections, and it's not linear. So what we should think about is always how to configure our device to avoid it and to test in a large scale. And one of the biggest projects I've heard is about it's stadium in Amsterdam, and there are, I think, 50,000 of bulbs, RGB bulbs, communicating between each other. So if that would work in a regular way, so just every bulb sending package in the air and every other just checking if, hey, I'm the receiver of that message, there would be huge mess, and there is a really low chance that that would be stable and successful. So scale in that terms really matters, and you just need to remember about it. The fourth one, think about the real user behavior, because that's I did this research like 2 years ago, just entered Internet of Things device, and Sonos, which is wireless speaker, was the first picture. So I just picked that and put it here. So what you would think about is probably to decrease volume, to start and pause, and probably to make a factory reset, to pair it with other device. But what can really happen when the user have the access to the device? What about disconnecting from the internet? So you just plug the ETH wire and then you disconnect it. So you don't have the connection. Or maybe the problem is between your router and your internet provider. It's not like you cannot connect to router because everything works fine here, but you don't have access to internet. So the important thing is to look from the user perspective and to create scenarios in a way that the user can really make something, especially when we talk about negative scenarios. The fifth one is CXA, and you can decode it as customer experience assurance. So how the user really receive something well, maybe examples, because examples are always better, and the pictures way is always more easier to understand. So just imagine you have LED communicating with, actually that's the protocol to communicate with external world. So LED, that always works, but me as a regular user, as just a person purchasing it and using it on a regular basis, I want to easily identify what is wrong. So when I see green light, my assumption is that everything is fine. And when I see red or blinking, then I have the I have the feeling that, well, that can be something wrong. And just imagine everything works, but you switch those colors. So everything is working, LED signaling is working, but the user, from his perspective, cannot really understand what's really going on. So that's what I call customer experience assurance. And the second example is when you have laser, and there's actually from my previous company. So it's camera for cat, and the cat can play with the laser. That's really fun testing, and it's recommended to have the real pet at your home or the office. But getting back to the point, when you have the laser, and laser works fine, so you can control it. But laser move from one point to another, and from another to just another one, not in a smooth way. And you can imagine that's frustrating for the user, and probably even more for the cat. So he or she cannot really catch it because it's in one place and they're in another, and it's not smooth. And what I would prefer is to not working laser at all, because I know there is something wrong with the device and I just send it back. When I see that kind of behavior, I'm frustrated because it's working, but not in a way I expected. And that's probably the best example. So that's another product that's treats launcher for pets. So you put cookies inside, and then you can launch into the air. So you just feed your cat in a more entertaining way. And the problem was that one of the influencers, one of the cats influencer, just posted a review that, okay, everything works fine. But the problem is that the launcher is launching those treats too fast. So the speed of those cookies is too fast, and the cat is just frightened. And if that's not working, well, I just send it back, and I'm waiting for the new one. And if that's working, but not in a way that the customer is expecting, in that case, the cat was basically stressed for the next couple of days, and because that was influencer. Well, that was quite problematic. So that's what I call customer experience assurance. So how you can mitigate this risk? Well, it depends. At first, you have customer support feedback. And the important thing is to have a good communication channel to provide always the feedback and to understand what your customer is really expecting. Then you have crowd testing. So just outsource this testing to the real environment. So we have the company in Poland or somewhere else, but the customer or the market is mainly in US. So sometimes it's better to test in the real environment. And the third one in that terms, because it's physical device, you need to sell it, and because you have sell it, well, Amazon is probably the most popular channel. And when we talk about Amazon, for some reason, probably you do the same. When I'm not really happy about the product, I prefer to post the review. When there is something working, when everything is working fine, okay, that's what I expected. But if there is something wrong, I can just parse those reviews and understand what is wrong, what the customer is not really happy about. And what can it be in that terms? Well, actually everything. It can be mobile app, because if mobile app's not working, people still post a review to Amazon that the product is not working very well. It can be connectivity issues. It can be one of the functionality. But the point here is that you can aggregate data and just parse it, and then you have information for free. Maybe not for free, because it's still your rate in Amazon, or for mobile apps it would be Google Play or App Store, but you have it. So why not to use it? Of course, if you have reviews in store, you can find the keywords, the buzzwords, and just draw as a chart, and then you can understand what the customer is not really happy about. The sixth one, and I think you cannot really scale it to software only, is that you work with the current, and there is always a voltage. It can be 110 or 230, it doesn't matter. Both of them kick you the same way. It's not very pleasant. Maybe some of you experience that. If not, I recommend not to try. But yeah, I'm still alive, so it's not that danger if you do it in a reasonable way. But you work with high voltage, so it's always worth to remember that you should protect it as much as possible. And one of my favorite stories is when we destroyed, I think it was one notebook, 2 mobile phones, and like 2 devices, and it exploded in a quite spectacular way. So a lot of smoke, some fire, but it was just one-time performance, and the cost connected with that was quite big, like 2 mobile phones and 1 notebook. It costs, and it's not possible to use it once again. But it's good lesson for the future, because when you do it once, then probably you won't repeat it. Well, if you repeat it, then there is something wrong with you understanding the consequences. But sometimes you need to make failure to learn from that. And if you learn from that, that's perfect. So the output for that, always think about how to isolate your environment. And the 7th one is about open source. So when you use open source, it's good to remember and good to have somewhere back in your head that it's not fully reliable. And I remember the story when I spent like 2 weeks trying to identify what's wrong with my environment, what's wrong with my infrastructure that cannot work. And after 2 weeks, update for open source came, and everything started working. So I understand that the problem was not with our part, the problem was with open source. But the painful aspect was that we spent 2 weeks trying to identify. So for that context, it's worth to remember that if we use open source, we should have, like, we can rely, but always remember that it's not 100%. Anyway, even if you have all those risk mitigations, even if you remember about all those 7 points, shit can happen, and that's normal. So just 2 examples. One is the company that created smart lockers for Airbnb, and I love that idea. So you have smart locker. If you are a renter and you are the owner of the flat, you just send, I think it was via NFC. you just send the, let's call it, ticket, and when you travel, you just take your phone, you come close to the locker, you take off your phone, and you can enter. You don't even have to interact. You can be far away as a renter, and everything works for you. The problem was when they updated firmware, so there was number 2 from our risk list. When they updated, something went wrong and all of them stopped working. So you can imagine, you came and you cannot enter, or even worse scenario, you went out to buy bread or a milk and you want to get back, but you cannot get back. So that was quite painful. And the second example, because it's close to my heart, so IoT devices for pets. And here the problem was not the device itself, but with backend part. So something stopped working, and there was a scheduler to feed your pet in regular periods of time, and it stopped working. And I love the advice from CEO of that company, just to not forget to feed your pet manually. And actually, that's the only advice you can give at that moment. So no risk, no fun. And what is so fun? Why there is so much fun when you work with that? Well, at first there is never just hardware. Hardware is just one part. You need to have backend part to store data, to parse data, to make an action, and then you just have to somehow provide your controller to the user. And usually, because it's a wireless device, you do it via mobile devices. Sometimes it's supported by web application, but most cases, and that's standard now, it's mobile application. So probably one of the most popular now is Xiaomi or Huawei. So you can aggregate all those smart devices into a single app, but there is no really useful web app. So there is never just hardware. The second one, when you work with that, then you can make just practical users at home, because you start understanding how everything works, and why not to scale it to your practical usage. And that's one of my favorite projects, because I had the same problem. So it's like semi-wild cat. So just cat going outside a couple times a day, and then getting back to eat and sleep at home, and then to go out again. And the guy decided to put the face recognition model to allow the cat to enter home. And there is missing part here because there are smart lockers, and they are unlocked when the cat is detected. And when there is no cat or a different animal, it's not. So locks are still closed. And the additional part for that was, like, you can hear camera, cat is detected. Probably if the cat is fully black, that's more problematic. But in that terms, it was slightly easier to make a image recognition, to make a to understand if the object is classified properly. And then when the cat came, there was a message sent to Slack. Hey, you can open the door, or the doors are open. And I know that the cat is back and safe. The third one, you work with awesome and new technologies. Just a few examples. It's smart home. You work with it's Amazon Alexa, but now you have more, not just Amazon devices to communicate with using your voice. Then you have Internet of Things, and much more. So you're really up to date with the newest technologies. And the fourth one, exciting real test cases. So getting back to one of our devices, it's Treat Launcher. Well, we had a lot of fun trying to find out the scenarios. And as I mentioned, those negative ones are sometimes even more useful. But then we missed one thing. So when the customer, when the user of this device went, let's say again, for a vacation and leave it to feed his pet regularly, we missed one thing, a negative scenario, that is not a problem with not working at all, but working too well. So there was a sun just directly on a sensor, and when there was a very, very sunny day, it was always active. And because it was always active, it was distributing food all the time. And probably instead of keeping your pet in a good shape, keeping your pet fit, well, after getting back from vacations, you need to send your dog to rehab. So what are takeaways from that? Just try to summarize those 7 points. The first one, always, and you can quite easily scale it to your mobile or web environment. So always be aware of flaky tests, how to handle it, how to avoid it, and finally, how to mitigate the risk connected with that. Because the risk mitigation is always something that you can always do before it happens. And finding out that flaky tests exist is already in process. The second one is connected with updates, and updates for physical devices, for Internet of Things devices, is probably one of the most risky areas at all. The third one is that scale matter. So if there is 100 devices and 200, it's not twice more. The fourth one is testing real user behavior. So what the customer, what the user can really do, what unpredictable can happen when I'm using this device. And closely connected with that, focus on customer experience assurance. So assuring the UX, assuring user experience to the customer, sometimes is even more important than, sometimes it can be more risky than functionality not working at all. The sixth one is limited trust in open source. And again, you can quite easily scale it to web area, to web environment. And the seventh one, well, IoT is hardware, hardware uses physics, and physics is unpredictable. And I wonder how many of you likes physics. I do a lot, and I did it during my studies and even before. But even if you don't really like it and you start working with that, then I'm pretty sure you will understand it better, and you will have much, much, much more fun because of that. And just have fun. And I think that's the most important takeaway from this presentation. Just have fun from that. So yeah, and thanks for the presentation. You can find me on Twitter or LinkedIn if you have any questions. And yeah, it's Friday, then it's Saturday and Sunday. So let's party. Thanks a lot.
Thank you, David, for your talk. We only have 1 minute, so we'll just take one question. We have a question which revolves around programming languages. We also a hint to one programming language in one of your slides, but the question goes like this: what programming languages are mainly used in IoT solutions testing? On which one we should focus more if we're interested in this testing direction? You have 20 seconds.
Okay, so the main language is Python, and there is a simple reason, because you can automate using it almost everything. So it's commonly used for embedded platforms, for pure Unix, for input and outputs. So in general, it's GPIO, general purpose input output. But you can then easily automate mobile apps and web. So it's just quite universal.
Excellent. Thanks a lot. Thanks a lot, David, for your talk. Thanks everyone for attending this very interesting talk on IoT. We'll reconvene in 5 minutes for the next talk on the QA and testing track. So see you all there. Hello all and welcome back. We have the final talk before lunch break. I'll quickly switch between my camera and the presentation. So making sure that everyone can see that now. Let us start. Welcome everybody. Now, when I was a small boy, I was a very big fan of sci-fi books, and I was captivated by the idea of imagining how the future might look like. And every book offered me a new view on this. Why? Because we don't know how the future will be. Later on, I started to enjoy history also, but sci-fi captivates me more. Each of these, sci-fi and history, ask for a different mindset to make the most of. Hello everyone, I am Florin Manolescu, Managing Partner at Academia Testării, and for the next nearly 30 minutes, I'd like to use your sci-fi mindset to imagine how the future of testing might look like. Now, in order to give the direction for this imagination exercise, I would like to set the stage for you. For this, I have prepared a couple of short stories that should help you get into this sci-fi mindset that I was talking about. Now, as a spoiler, none of them have anything to do with testing or IT for that matter. Some time ago, I've read an interesting book. While it was not a sci-fi book, it raised an interesting subject to my attention. To emphasize a theory that I will share with you soon, the author looked at, with the help of a graph, at the first 1,000 days in the life of a turkey. During this period, all of the actions that the humans performed in relation with the turkey implied the belief that humans are looking for the turkey's best interest. However, day 1001 came, and guess what? That was exactly Thanksgiving. Can you imagine the shock and surprise of the turkey? The turkey just experienced the dramatic impact of a black swan. This is a theory defined by Nassim Nicolas Taleb in the book with the same name. Up until 1697, no one has ever seen a black swan, so telling someone before this time and some significant time after that a black swan existed would have totally upset their reference about black swans. Now, the black swan is defined as an event that creates an extremely powerful impact, which is impossible or nearly impossible to predict with our normal eyes. And this is why I'm bringing the black swan into discussion at this point, to help you gain the special eyes needed to predict or imagine how the future might look like. Now, there are two types of black swans. There are good swans and, of course, bad swans. And I'll show you the difference between them in a second. Say that on the 10th of September 2001, a US judge decrees that all plane doors, now I'm talking about the pilot doors, need to be bulletproof, closed, and secured from takeoff until landing. People might think of him as crazy, but life would go on. That was a good swan. Unfortunately, in this case, the bad swan happened the next day on the 11th of September, when we all know of the dramatic terrorist attacks that had. Moving forward with our setting the stage, we are coming to our current days. Well, what I can say that today we are actually living the effects of another black swan. A bad one that changed how we see interaction with each other, but also one that is turning on the heat for the digitalization race even higher. I hope that adding the black swan theory next to the sci-fi mindset, we can look where we are today and start imagining how the future of software development might look like. looking at how we develop and deliver software, we have three main categories involved into this activity. We have, in no specific order, processes, people, and tools. If we start analyzing processes, we all should start from the famous waterfall, agile, and Kanban approach. Right in here as a process, we can also add the software testing process along with other processes that compose the SDLC. These processes have some characteristics that make them adapt to an organization context, because we don't take them for granted and follow them, let's say, by heart. Some of these are best practices related to a process that the organizations want to adhere to. Now, also within this, we have, let's say, deviations or adaptations, like, let's say, the V model for waterfall, the Scrum. But we also have quality gates for every process, which are the safety measures that come in addition to the best practice, and these safety measures should drive the process quality. Even if we started talking about processes, what drives any process are the people. Now, these people act in different angles in order to deliver on the complex task of building software that works and has quality embedded. Whether we talk about project managers, analysts, developers, DevOps, testers, or system architects, the people in these roles bring their specialized contribution to the delivery success. If we only think within each of these roles, we have multiple specialization that we can recognize. For example, for developers, we have front-end developers, back-end developers, full-stack developers, possibly even a language-specific development role. If we go on testing, we have manual testers, automation testers, performance testers, security testers, and we see that quite a complex matrix of people and roles starts to be created. Now, on top of these specialization, we also have the seniority to factor in, which creates a huge impact. The key fact is, however, that with all of this complex possible matrix of people, all of their deliverables, all of our deliverables are digital. Here come in the tools that help us to produce our digital deliverables. Also, these tools can be classified. We have some that we use to do our work. For example, in QA, we have the test tools. Some tools we have that are being integrating the work of one profession or one role with the work of another role. And we have some other tools that are being used to support interaction and integration between professions. Like, for example, let's say the tool in which we ask for holidays. Having sketched the flavors of the software development practice, I would like to give you something to think about, not only in the lunch break that will come after this talk, but also after. I will also call again on the sci-fi mindset that I have been talking about in the beginning of the talk. I tried to imagine a path to where we might go. Along the way, I have highlighted some milestones that I think will represent turning points in this envisioned path. We always start from where we are as the first milestone. This is because our reality is what influences how our future could look like. And here we had the development processes that we've discussed. The next step, or let's call it the first actual step, would be the AI revolution. Not like in the Terminator movie, but more like when advanced AI technology will become widely available. Having this embedded in multiple devices and tools would change the way we interact with machines and a key driver to this will be when people start to become comfortable with the technology. Now, we are still in the early adoption part of the technology, and as you can all see, there is still some way to go until this technology becomes widely used. Why am I emphasizing this technology? Because it would make our life and work easier. Now, the third step would be the tool revolution. Once the technology will be widely available, it would not take long until we find it in our tool stack. This would mean that our tools will start to be autonomous, or let's say we'll need minimal operational assistance. You will be able to say things like, test this website, test this app, test this database, or test this API, test this flow, and test it from an end-to-end perspective. And then you will receive all of the execution report with great coverage, defect logging, and everything you need in order to make an informed decision about quality. Now, when these next-gen tools will start to be used, they will come with integration capabilities. Among these capabilities, the integration will come with other profession tools. This start of movement will be of key significance to us, because what it will do is that it will give the kickoff for autonomous development and delivery. This will be the key defining moment, the one that, and this is the moment when the tools will gain the capability to develop end-to-end autonomous capabilities. This will mean they will understand business requirements, translate them into code, build, test, and deploy. So the focus that is now moved on building a delivery pipeline and a continuous delivery pipeline will be incremented with autonomous. Now, what about us? How we will cope with this? With this projected image of the future. Of course, there will still be humans involved in every step of the delivery pipeline, but I think that their role will be mostly to operate and validate the tools, tweak and maintain the system. Now, other specialization might appear, like interacting with the tool algorithm to refine efficiency and organization at organization level. We have, as humans, some capabilities that are quite unique and difficult to simulate through AI. I have a little video in here from Jack Ma, the founder and CEO of Alibaba Group, that tells us a little more about these human capabilities. So as a conclusion, while we can't predict the future, we can say for sure that technology will be a part of it. This with the assumption of no major black swan along the way to upset this. Technology, from my perspective, blends with the idea of AI, so a future where autonomous testing is being done as part of any build at configurable coverage ratio with excellent and relevant test data does not sound that bad. I'm really curious to hear what your thoughts are on this, either now in the comment section or later on. You can reach out to me by email or in the conference. I heard some feedback that there was no you could not hear the sound. Let me paste that for you in here so you can still have a glimpse of what he saw. Basically, I'll resume that I'll recap that for you. He says that we should focus our teaching and what we specialize in the soft part of the curricula, let's say teamwork, being empathic one to another, developing the soft skills that the machine are not so will not learn so easily and will not do that easily, because moving on 30 years from now, if we continue to teach knowledge-based knowledge, then the machine will do better. So we need to rethink how we position ourselves into the more, let's say, soft parts of the profession. But I will share with you right after this. I'll share with you all the video from Jack Ma to hear it from himself also. So thank you very much for your time. We will now take the lunch break. We will reconvene on the next talk at 1400 hours for the second round of the day with great speakers. Looking forward to seeing you all then. Bye-bye. Hello, guys, and welcome back. I hope you had a good lunch. And contrary to the laziness that you have after lunch, we came back with a lot of energy. We have Viv Richards here with us, lead QA consultant. He will help us spot the difference and help us understand how automating visual regression testing works. Viv, the stage is all yours.
Thank you. Hi everyone, my name is Viv Richards. Thank you very much for the introduction, and it's a pleasure to be sort of able to still present given the circumstances. If you can bear with me, I've got 5 young children that are sort of roaming the house, so I've asked them to be quiet and try to bribe them, so we get on. So yeah, in this section we're going to look at why manual testing alone often isn't enough. Why automation can sometimes seem like too much effort and you don't get a lot of value out of it. We'll be looking at visual testing, and this isn't sort of some tool that you can buy. It's something I sort of created as a proof of concept, and it's available open source. I'm not trying to push anything or sell anything. And then we're going to be looking at common pitfalls with visual regression testing as well, and some ways that you can start to overcome them. So why automate end-to-end UI tests? It may seem like a silly question. But automated testing, it can be more reliable as it's performed by tools and scripts, and because it's executed by software tools, it can be faster as well than a manual approach. We're human, we get distracted. If you work as part of an agile team, there's lots of ceremonies and things that sort of break up the day, so it's hard to try and get into some sort of rhythm or routine. So if you've got something that's sort of running, executed by yourself, then obviously that frees you up to do other things. There are some common automation issues, so investment is required, and that's not just to buy a tool off the shelf, it's the investment of upskilling people on your team to ensure that they understand how to use that tool, and they perhaps need to understand programming language to be able to write the automation. And it's only really a practical option when test cases are run repeatedly over a long time. So if you're trying to automate something that you only need to run once or twice, you need to weigh up that investment, because it's probably not worth the investment. You need to do that ad hoc thing manually. And the most important thing, whilst this doesn't always matter for this talk, automated testing does not entail human observation. So whilst they can say that an element exists in the DOM, or the document object model of the website, it can't actually say, it looks. Yeah.
Can you check the share option, because you're sharing your presenter notes? Yeah.
Okay. Sorry. Is better? That better?
Excellent.
Yeah, sorry about that. Sorry, so yeah. The problem is that with a lot of automation, whilst it can say, especially with the new release to Selenium 4, it can say that an element is to the left or to the right. It can't tell you that it actually is the color you expect, the right font, the right position. So there's these types of things that typically you'd need, something extra. You need that manual check to verify that something is the way that you expect it to be. And it can be a slippery slope, because I've seen this quite often, whereby you ask someone who's learned or picked up a tool, can you do something simple? So like in this daft example, somebody's asking to pass the salt, and the team member, instead of just passing it, they're writing the script. So it's overkill. They're trying too much. They're over-engineering the solution. Sometimes manual is the best approach. So for those that haven't seen this or aren't aware, or for those that are, I'm going to cover it anyway. So this is the ice cream cone anti-pattern. It's the reverse of what you may be used to. And what this depicts is that basically you have higher up the pyramid you go, there's more cost associated with implementing and maintaining tests. The lower down, the cheaper they are to implement and maintain. So likewise, the lower down you are, so for unit tests or integration tests, service tests, they execute quicker than UI tests. And so further up the pyramid you go, tests become quite slower. And you're always going to have at the top of the pyramid there's always going to be an element of manual exploratory testing. It doesn't matter how much unit integration, service UI tests, visual tests, there's always going to be this need to check and validate that things are the way that you expect them to be. So I've been on teams whereby they've had a very top-heavy, like the previous slide, test strategy, whereby they had a lot more UI tests than unit and integration tests. And the problem is with that, as I mentioned, the slow feedback. So what you want to try and do is push the test further down the stack, and you can do this in multiple ways. Some of the ways that I've tried is to pair up with developers to do sort of test-driven development. So I know that it's one of those subjects whereby not everybody agrees that testers should be involved with developers in TDD, and typically it's pair developers. But personally, I think that testers can add a lot of value in pairing with developers. Testers tend to have a lot of business logic and domain knowledge. And they can help to sort of think of edge cases and things with the unit and integration tests. So that way you can push, instead of testing the UI level, you can push the test further down the stack. But I've been on teams where they've tried to do that. Instead, they end up with something like this, whereby they have the UI tests, which are now a lot less, and they've got unit tests, which is great, but they lack in this middle sort of section. And the problem with this is that even if you know that the tap works in this example, when you put the tap to the sink, if you don't have integration tests, it doesn't matter how many unit tests or UI tests you have, you need to have confidence in all the levels of the testing that you sort of try to do as a team. And it's something I like to call fragile testing. So, when you're sort of relying on the UI test, you're not getting that feedback. You want to fail fast, and you want to be able to adapt to change. So you need to have the tests further down the stack so you can start to get that feedback quicker. So this is perhaps what you're more familiar with. This is an adaptation of Martin Fowler's testing pyramid. And whilst, again, not everybody agrees with this, it's something that I like to sort of look at to try and help show to teams or explain to teams that there is value in pushing the test further down the stack, because sometimes you see that lots of people will have lots of UI tests, and you really get the happy part or the critical part of their application. Logic can be tested further down the stack and give that quicker feedback. So I've already said that UI tests can be quite slow, and manual exploratory testing, while there is always a need, is slow. Why not stay with it though? Because it does allow for human observation, which is really important. Problems, again, can be time intensive. It's not accurate all the time due to human error. Of course, scripts can be wrong as well, but we get distractions. There's lots of things to try and prioritize and do within a day, so it can be quite tricky. Time consuming. While you're manually testing, you can't then, if you're running through some test scripts, you can't take your time to do something else. So it's very time consuming, and it's only practical when the test cases are run once or twice. If you need to keep running over the same steps, then perhaps you need to be looking at automation. But the problem is I've been on teams again where they've created frameworks and tools and things to help teams to write tests. And it's not just testers that can write tests, developers can write tests, and they should be. But even when you give them the tools and you try to give them the wheels for the cart, like in this cartoon, the problem is people are too busy. They say, well, sorry, at the end of the sprint, I need to automate, but there's never enough time because we need to start the next sprint and get things up the door. But it's a catch-22 because they don't have time, because they don't, automate, and they don't automate because they don't have time. So they're just stuck in this cycle, and they need to try and break that, because unless you break that cycle, you're never going to be able to free up your time to prioritize on really the critical things. And there's many options. So when you're looking at test automation, there's so many different things to consider, and it's like Visual Studio coded UI. So this is like a little application whereby you can just click records, navigate to a website, it'll record the steps, and then you can do some sort of verify statements. There's some things that may be for Android, so Selenium, Appium. So this will basically allow you to extend Selenium, whereby you can point your tests at Android or iOS. There's lots of things. Cypress, so this is fairly new, a couple of years old. A lot of the solutions you see online are sort of some sort of wrapper that sits on top of Selenium, which is probably the most popular web automation tool out there. But there's just lots of different things to consider. Again, Visual Studio coded UI, the last time I checked, it only allows you to record and play back on IE. Some of these are for Android, some are for Chrome. I think Cypress is limited with the browsers it supports as well. So there's all these different things that you need to consider. And lots of these as well have SDK, so you have to perhaps write code because they don't have a UI to record the tests. There's just so many different things, and it can be quite difficult to try and work out what the best tool is for the job. So typically, the tool that I use, as I mentioned, is Selenium. I really like it because it's open source. You can see the code, you can help out. There's a massive community support. It can operate on almost any operating system. There's multiple language support, and it supports a range of browsers. So when I was coming up with this proof of concept, I was trying to get the businesses buy-in for a visual testing tool. We were using .NET, and we had to support Chrome, IE, and Firefox. So this was ideal for us. But the problem is that I think people, when they see things like Selenium or these little play and record things, or record and play, they think it's a silver bullet, and it's not. It's just another level of sort of checking. You know, it's not testing. UI Selenium tests aren't actually testing your software. They're checking the things you told it to. So just be mindful of that. And there's issues. So when you look at like browser compatibility, each browser, sometimes you have to interact with it in a different way. So if you have a Selenium script that has to interact with a few elements and click a button, in one browser you may be able to find element by ID and then .click. Another one you may have to do find element by ID .send keys enter. So there's different ways in which you have to interact depending on the browsers, and then all of a sudden your test scripts can become quite involved and hard to maintain. And also then the execution speeds of the browsers are slightly different. So sometimes you'll have to try and slow things down or add checks to try and make sure the elements are displayed properly. And rendering differently. So whilst it's not a problem for typical UI testing, when it comes to visual testing, it's really important this point because browsers do render differently. For execution speed as well, when you've got lots of tests that rely on this testing at the UI level, I've seen tests that take up to 15 minutes to execute and produce a result. And it's just not quick enough. Again, maintainability, you know, adding weights, different ways to interact with the element, it all becomes quite a chore. So if we look at this example, so how valuable are these tests? All it's doing is, so here we're saying C# code, we're asserting that the driver, when we find the header one element, the text contains contact form. And we're doing these sort of checks for each bit of text on the form. It's great that we can assert that the text exists, but how much value is actually in just doing this type of check? I've seen test suites that all they seem to do is just go onto various pages and check text. So it may be worthwhile for something like localization testing, where you want to check different languages, but you know, it's not the best test in my opinion. So one day I was working at a company and they had a application and they had these types of checks and they were all passing on the build. You know, confidence levels were high with the software. They had a call in support and the person basically, this is what they saw. It was a contact form and they just had no way to proceed on the form. So the support clerk checked the text, they were all passing, went into the application. There was a problem. There was no button to actually interact with the application. There'd been CSS breaking change, the element had been hidden off screen, and so there's no way visually for the person to actually see how to progress with the application that we're using. So once the test passed, because the element was somewhere on the DOM and the test found it, the button actually wasn't visually there for the person to use. So some of the things, just before we get into visual testing, I just wanted to touch on very quickly was that you see this a lot and it can become quite difficult to maintain your test. So things like page object patterns, there's a link here from Martin Fowler. He explains it a lot better than me, but when you're interacting with elements, like we saw on the previous page, and you're just hard coding strings, it can be very difficult because if an element ID or attribute changes or text, you've got to go through all your tests to update all the different places that the text has changed or the ID or the class of the element. Page object patterns help you to extract out that interaction in one place, and then all your tests reference that object. So maybe you've got an object that's a label, and you want to check its text, you move that out to one common place into a page object, and all of your tests refer to that object. There's a nice way to try and maintain your tests. Very quickly, QA selectors. So if you're finding that you're trying to automate the page and you can't quite work out the best way to interact, one of the things I've done previously. So if you look at the top of this page, this is the standard sort of HTML for the page. You can see there's a class button, and the only difference here is there's a type button, type submit, value cancel, and value submit. What we've done is we've worked with developers, and we've actually added these things called QA selectors. So QA hyphen, the element type hyphen, and then the text or the value of the button. Other people have used these as data attributes, but what these allow you to do is they clean up your tests, because when you're starting to write your tests, because you've got these QA selectors, no longer are you trying to do driver.findElement by ID or class name or XPath. You know now that you've got these elements. So if you do driver.findElement by class, you know that these elements are going to be here. And also when the front-end developers making changes to a web application and they see this element, they're going to think, hang on, there's a QA selector here, or maybe you've got in a data attribute. So they're going to be less likely to make a breaking change because it's very visible compared to at the top where it's not visible that this is even being used by an automation test. So it's just something to consider potentially. So I know lots of people have just had their lunch. It's 12:15 here in the UK, so not quite yet, but to try and keep you awake and keep you sort of engaged, I wanted to sort of play a game. So it's the first of two games, and what we're going to try and do is see how many differences you can find. I'll give you just a couple of seconds, maybe 20, 30 seconds, and then at the end we'll run through the changes. Appreciate it may be difficult to see depending on the type of screen you're using. Apologies. Okay. So at this point, I'd normally ask around the room how many differences people found. It's quite difficult. Hopefully you were able to find a couple. So what I'm going to do is I'm just going to run through some of the changes that I made to try and show how difficult it can be when you're up against time constraints and you're manually checking these things. Perhaps you've got UI tests, but how many would have been picked up? So there were 7 differences. Hopefully you found a couple of them. So using a typical sort of UI test, using Selenium, the DevTalks logo was altered. So there's the / and angle brackets. This is an image, so this wouldn't get picked up typically by UI test. Next, we've got a link. Exhibitors has got an underline. So this is a styling change. Again, it probably wouldn't get picked up unless you're doing some sort of property-based testing, which you could do. But again, you have to weigh up the value of it, I guess. The third change is there's a Z for partners for the link. So this is a text change. This, like in the previous examples, this would have got picked up because it was a text change and we can check the text. The next change is a white line as part of an image, which should be red. So this wouldn't get picked up. Again, we've got a padding change. So in between the sort of hook text and the image, there's padding difference. This wouldn't get picked up. And then the last 2 things then, we've got text, which is changing because this is a this changes every couple of seconds using JavaScript. So this probably wouldn't get picked up, because unless you put a wait and check through all the text. And finally, there's an OK for a cookie banner, which should be OK, thanks. So we can see that using Selenium, we would have picked up 3 of these text changes. There were 2 image and 2 style changes. We just wouldn't have got picked up. And it's very easy to miss these types of things when you're working for, important clients. Some of these things, when it's branding or something like that, it can be very costly to a business. And the problem is, how do you know when you found all the changes? How do you know when to stop? As with any testing, it's very difficult. So moving on to visual testing, how can we add more value then to our UI test? We've already said that, or I've already said that they're very slow. They're quite involved compared to service, integration, and unit tests. But how can we start to add value then to the manual exploratory testing and UI and try to save some time on some of these checks? So if we could simply say, I've got this base image, so I've taken an image and I've saved it on my in my project, and I want to just navigate to that website in the new browser, take a snapshot in memory, and say, does this image equal the new image, the current state of the web application? So when it comes to visual testing, these are just a handful of tools. And again, like with UI testing, it really depends on so many different factors. Not all of them are free. Some of them are free initially, while you get so many screen captures. Some of them have a UI, some of them don't. Lots of them, as we'll go into, and you'll see some of the problems, just do pixel by pixel comparison. And depending on the hardware that you write the test and then you run the tests, if the hardware is slightly different, you'll get rendering differences, and because it's pixel by pixel, it will actually pick up different changes. Some of them, as the name suggests, so Backstop.js is JavaScript. So if you're writing UI test in, for example, C# or Java, do you really want to then add visual test in JavaScript? So there's lots of things to consider there. I don't work for them. I always talk about them because I really like what they do. They offer free tools as well. Free trials. So Applitools is the most advanced of all of the visual testing tools out there. It has, you can use Cypress with it, you can use Selenium, you can test mobiles. It's just a really nice tool where you've got a nice GUI, you can write using their SDK. It's really clever because it can actually allow for certain differences that some of the other tools would pick up and throw errors, and it allows you to cross test lots of browsers. It's definitely something to check out. So the issues with the other offerings, when I was trying to implement visual testing, the issue was that there was a cost, not only for me to spend time in Spike to actually try this stuff out, but there's a cost in, getting a tool, and they didn't want that cost. So Applitools, again, whilst this is a fantastic tool, it can be quite costly if you've got a large team and you're running lots of tests. But for us, lots of the other offerings from the previous page didn't work straight out of the box, or they contained lots of bloat. And again, it was a steep learning curve because there's lots of people on the team who were typically used to just running through test scripts. We tried to create helpers to get them involved in writing UI tests. And there was just then that another level of complexity to try and get them to write some visual tests as well. Some of the tools were quite new, so there's a small community, so the lack of support wouldn't be there. And the most important thing that I was trying to address was that we needed to work with the current automation framework. We couldn't have some tool or framework that was another level of complexity. Again, the costs to buy the tool and implement it was a major factor as well. So we decided to roll our own, and it was in development for just over a year, primarily because there was just myself working on it initially. And we faced many challenges, and these were probably, to be fair, because of the products we offered and the ways we developed them, and the way in which we tested them. So these caused lots of challenges for us. Perhaps if you use some of the other tools, they may be better suited for you. It's like UI testing, it's not one sort of size fits all. It's one of these things where you need to try it and see what works and what doesn't work for you. Reliability, so I mentioned earlier that browsers render differently, and this really matters for visual testing. So what you see here is a Google homepage, snapshot of Google homepage taken in Chrome. We run the test in Firefox, and all the pink boxes you see are all the places where framework we were writing thought there were differences. But actually there were no differences, it's just the browser rendered things slightly differently in that browser. Execution speed. I wanted to try and show how quick the browser could take a snapshot of a website and check text, fonts, colors, padding, everything. So here you see the test ran in 4 seconds. And what this did, I declared a base image, and that was an image I'd taken with this framework and stored in the location. I give it a website to go to, and then using this tool, I said, well, using this image, compare that with an image of the website as it currently looks for this URL, and set the difference to 0. And it did all that within 4 seconds. So I want to take this further. We're going to play the last game before we run into some of the visual testing problems and ways to overcome them. I wanted to try and show to the business the real value in when there's lots going on and there's lots to try and, if you're dealing with languages you're not familiar with, it can be very difficult to pick up on little things. So we give the tool 2 images, and one of these has got Wally in it and one hasn't. So if you can find them. Okay, so I appreciate it's difficult to zoom in a little. And it's the thing, even when we're zooming in, there's just so much stuff. In reality, the UI that you're testing, I hope, is nowhere near as complex as this. But what I'm trying to illustrate is there's lots going on, not just in the UI, but in the environment you're in, that can cause distractions or make things quite difficult to find. So for the eagle-eyed people, who's up in the corner. So it's very difficult. Again, I appreciate that this is a very sort of over-the-top example. I'm just trying to illustrate that visual texting can pick up things as minute as this, and in seconds. And think how much time you'd spend on, trying to highlight a difference between some text in a document or something like that, or text on a website that you perhaps aren't familiar with. So the machine was very quick. I'd be surprised if anybody at home managed to find the image this quickly, but it was 293 milliseconds where we passed an image with WALL-E and an image with no WALL-E and compared the difference to try and ensure it was 0. The image you see at the bottom is a lot of these frameworks, they'll actually output a difference image. So when they fail, they'll render the image and draw it like these pink boxes around it, so then you can see perhaps as part of your pipeline in the artifacts, you get this image so you can see where the issue was. I know a lot of the tools have dashboards, so you can link it up to your pipeline, and when the tests fail, you can say, actually, this was an expected change, and you can then update your base image, which we'll go into in a second, or you can fail your test. It's a nice way that can control the flow of your test. Maintainability. So if we look at the old code again, where we had these sort of 6 lines of code where we were checking the text, all of a sudden with visual testing, just by declaring the image, the URL, and then checking for a difference of 4 lines of code compared to 6. And all of a sudden, we're not just checking the text now, we're checking, does the contact form have a green font of this type? The subheading text, the alignment of things, the padding, space and colors, we're getting all this extra value. And it's just from one simple check, and you can take it further again. So if you're used to something like SpecFlow, what you can do is you can take the code that I had just now, and I showed you with the URL and the image, and you can sort of reuse the code again. So there's lots of different ways, as with anything, to do things. This isn't my preferred way of using Cucumber. Cucumber should be to drive conversations, and it should be for the business. But you can use SpecFlow to have scenarios whereby you say, when the URL is visited, and you can use it as a parameter, then the page should match. You can give the URL with a link to the image. So you could have lots of scenarios with each page and image, but actually the code is the same. You just pass it through the parameter for the URL, and then you just check the base image that's passed in for the URL. So all of a sudden you could have 20 pages where you just list, copy and paste, and change the URL and the image, but this code would never change. This is all the code you need to check the text on 10 pages. So you can see the code to maintain now these snapshots and comparisons. It can save a lot of time in trying to sort of automate the UI and check for these types of things on your page. Again, it allows you to easily identify differences. So each visual testing tool is slightly differently. The tool that I'll share the link at the end, which is on GitHub, we had 2 options. We had one where it just draws the boxes. When it finds differences, it'll draw a box. And the reason it found the difference here was because the Google page was animated, so the O would move, and there was like a throbber effect where it sort of zoomed in and out on the text box. Sorry, and on the right-hand side, you see the numbers here. So this is all the places where the difference image, we thought there were some differences. So you can see on the right-hand side, there's 27 tolerance difference. And you can see all the differences. So what this allows you to do is, when you're dealing with pixel by pixel comparison, you need to be able to set a tolerance, because as we'll go into in a second, things render slightly differently. You don't get that with the AI tools like Apply tools, but if you're using something that's like the tool I'll share, then you need to start to play with tolerances, because it becomes quite an issue. I was writing tests, I was checking them in, somebody was pulling down tests and running them, and then they were failing because of the tolerance levels, because they're anti-aliasing basically. Accuracy. So it can be pixel perfect. What you see here is pink boxes highlighting the area of change, and there's the black dot in the bottom right-hand corner. So this was the dot that I put on the web page, on the image, sorry, and it picked up the difference. So it can be pixel perfect if you run the test on the machine that took the images. Image quality difference, again, if you take the images off the same machine and doing a comparison on the same machine, then regardless of if you're running a test via Appium to test on an iPhone or iPad, desktop computer, there is no difference. If you start running tests on different machines that didn't take the base images, then you're going to start running into some of these issues. And a lot of the tools will help you to deal with these differences using AI again. But in these examples, I'm just trying to show you ways to overcome them if you didn't want to pay for a tool such as ApplyTools. There were many challenges that we faced. Maintaining base images can be a pain. So think about the browsers that you want to support. Again, something like ApplyTools, you wouldn't have this issue. But if you're rolling your own solution, if you're trying to take snapshots for IE, Firefox, and Chrome, you need a base image for each driver type. If you're trying to take snapshots of different sizes, you need a base image for each size. A lot of these tools, like ApplyTools again, you don't need to concern yourself with this. You just take one snapshot and it'll do the rest for you. If you roll your own, you need to start thinking these types of things. Screenshots, so you can take down to an element level of a page. You can take by a div or class, so a section. By default, W3C just takes the viewport, but our tool and the other tools, they actually stitch together. So you can do a full page screenshot. So you could do your branding. So you can say, are all my buttons and headers as expected? You don't need to take a full page screenshot, do your visual comparison. This caught me out. It seems silly, but I wanted to share it. I wrote some tests and I checked them in, and it came up to the demo of showing this framework that I'd built. And the problem was that in my Selenium tests, I was actually maximizing the window and taking a screenshot. Now, when you've got screens that are actually different sizes, when it takes a screen comparison, the images aren't going to match. So there's a little tip. If you're going to do visual testing, don't maximize the page, because that way it doesn't matter. The screen resolution won't affect your screen captures. Responsive design, I touched on briefly. You can set up little profiles, if you like, in your tests. You can say, open the browser with this height and width, open the browser in Appium, open it in Chrome, this height and width, Firefox. And you can start then to take snapshots of your responsive site. So you can try to help, you could have a desktop site and then a smaller one using the devices from Chrome DevTools. You can enable that and you can take snapshots. Just really, really flexible. This is what I've been touching on. This is the tolerance level. So when you do pixel by pixel comparison, what you see is, to the human eye, things look the same, but to the hardware, things are rendered slightly differently on different machines. So whilst this page may look the same to your eye, you're going to run into these issues when you run tests on different machines. So if you're using pixel by pixel comparison, they'll offer an output image, which will output something like this with numbers. You're probably going to want to pick the highest number, so 27 in this case, in your tests. Whilst it still isn't pixel by pixel perfect, you'd still pick up, for example, if I'm feeling lucky said, I'm feeling sad, or something like to that effect, it can still pick up changes. It's not to the pixel. Again, other tools they cater for this using AI. Storage can be an issue, because if you've got lots of images for different browsers, for different sizes, you need to start considering where are you going to store these images. And it's not just the base images, it's the images that are taken when the tests fail as well. So for every test that you run, for every browser, for every size, if that test fails, it's going to output a different image. So you need to start thinking, where am I storing these images? Do you need some sort of cleanup policy, or do we even need to automate all of these browsers? How much value is it actually giving me compared to the sort of cost in maintaining all these base images, all these different images? Again, some of the tools help you with nice little dashboards with this. But in this example, we didn't have that sort of luxury. Dynamic content. So if you're dealing with perhaps applications that are data-driven, like WordPress or Drupal, or in this example, we had a meetup page. You've got a section of the page that always changes when people RSVP or or they decide they no longer want to go to the meetup. So a lot of the frameworks, including this one, what we do is we find the element, we create a helper, so we can find the element by class name. And what it will actually do is it'll find the height and width and top and left of the location, and it blankets over it. So that way, when we take a screenshot, because there's a blanket over that dynamic area, it doesn't matter what changes underneath it. Snapshot will always be the same. The dynamic element is just covered. Just one way to start to think about overcoming some of these issues. Moving elements, so CSS animations and videos. This can be quite tricky, but there's a little known thing, or little used thing in WebDriver, whereby you can say driver.execute script. So you can actually pass in JavaScript into the browser. So doing that, you can disable CSS animations or videos. So like in the Google example where the page was just playing like a Google animation, you can inject the script before you take the screenshot. So you do the driver.execute script, pass in the JavaScript to disable the animation or video, and then you'd run the helper to take the screenshot and do the comparison. You can do that regardless of the framework you use if you use Selenium under the hood. On the little known things, there's 3 quick things before questions. You can use this framework and other frameworks to visually check documents as well. So say you've got a document that's 30 pages long in a couple of different languages. We had the GDPR updates a couple of years back that we had to run through. You can feed in a PDF into the tool, and you can say, I want this page, or I want all of the pages as a PNG or GIF or JPEG. And then you can run that through the comparison. So quite quickly, you can compare a PDF page and say, does this PDF version look like the version I've got on my machine, or what are the changes? You can highlight them. Previously, this would take a business analyst or somebody like that quite a while to go through each document to see where the updates are and what the effect is of that. And these tests can run in seconds. So whilst the test I showed earlier in Selenium, the UI test, did run in 4 seconds, bear in mind that when you're running tests, they have to log in and they have to navigate to a certain page. You've still got all of this sort of setup time, if you like, that you have to account for. The time saver is in, instead of checking the elements, it's actually comparing screenshots. You've still got all of that time, regardless if you use visual testing, to actually get to the point that you want to compare the screenshot. PDF dynamic content. So yeah, you can compare the dynamic content and blanket over it like we did with the UI tests. This is a really nice way if you've got dates, perhaps. So we had a document where we were stamping the date and signing a document. That will cause an issue if you keep running the tests, unless you use a dummy user that's used in all your tests. But you can dynamically cover content within PDFs. It's a really nice thing. And again, there's examples in this source code I'll share. Some of the things you may be able to just use as you wish, basically, and complement other frameworks. But it's sort of, again, it's not a one-size-fits-all. You need to try it and see what works for you. I've used it for visually checking charts. So whilst I couldn't check the data, I had a driver executing script and injecting data into my D3 charts. And then I was able to then check, actually, the charts rendering the way I expect them. So I'm expecting a donut chart with X amount of sections, or bar chart with 6 bars of certain width, certain colors. You can check all these types of things as well. And finally, an area that's sort of not very much explored with automation, accessibility. So you can execute script into the browser again, and there's a snippet that's in the repository that you can inject into the browser, and it'll actually draw the lines that would be the path. So if you tab through the application that you test, one of the tests that's for accessibility is that you need to be able to tab to every control. So with this, you can execute JavaScript. It will tab to each control and draw a line, take a screenshot, and then if you add another element or you move an element, you run the same test again. And you can see if you've broken the tab flow for accessibility. Just another way of trying to sort of think, how can we save time with some of these things that previously you couldn't automate? So finally, hopefully that's whet your appetite for visual testing. I really hope you'll try the repository that I've shared here. You can go to this website and you can download the repository, or it's .NET, C#, sorry. Or if you're using .NET, you can run this command, install package, automate visual testing. And within a minute, it will pull down all of my examples, all the different types of things that I've tried to share with you, lots of tests, and you can run them and see for yourself how it works. So that's all I had prepared. Thank you very much for your time and listening, and I hope you enjoy the rest of the conference. Thank you.
Thank you, Viv, for this very interesting talk. We do have quite a few questions. I'll try to group and ask some of them in the time we have left. First, there were a couple of questions around the tool and the framework. So can you please just tell the audience again what tool or framework was used in the demo?
Of course, yeah. So sorry, I touched on it very late on the presentation. So the framework was something that I've shared a link to. I can share via Twitter or something, or with the organisers anyway. But it was used in C# and .NET, and it was a very lightweight sort of helper class, if you like, just to be able to piggyback off Selenium WebDriver, just to take snapshots and do some of the examples that I showed you today.
Okay. Now, the second question is, in order to get rid of browser rendering differences, should we take different images for all type of browsers we are going to use for tests?
So again, yeah, like I covered, you can take a base image for each of the different browsers, but again, sorry, so I always keep mentioning Applitools. Applitools, what they allow you to do is you take one base image in whatever browser you like, and then they have something called, I think it's called Grid, and it'll test all the different browsers and devices instantly for you in seconds. So whereas you may use something like Browser Stack and have to manually test or change your tests to look at each browser, they do it for you and they manage the base images. So in my examples, you would need to take a base image for each of the browsers to manage the differences, unfortunately, unless you use tolerance.
Okay, thank you. Another question goes like this. Are you saying visual testing should complement UI Selenium tests? Are these faster?
Yeah, so again, it's not a one-size-fits-all. In my example, the visual testing framework I used was complementing Selenium. I think if you're doing a lot of checks on your tests, in the UI tests, and you're finding that maintainability of the tests are quite a pain, it's definitely something to try and see if it works for you. Again, I can't say, yes, definitely use it, because every application and every sort of need is different, but it's certainly something to try out and see if it is right for you.
Okay, thank you. One more is, how do you handle dynamic elements like dates or counters when you do the comparison? Will that fail your test?
That's a good question. So, like I briefly showed, a lot of these frameworks, including the one I demonstrated, they actually give you a way to blanket over dynamic elements. So you say what the element is that you want to cover, if you like, and the helper will find out the location, so the top and left of the element. You'll find the height and width, and then just blanket over it. So that way, then you don't have to worry about the counter changing. The other thing I showed as well was that you don't have to take a full page screenshot. You can just take a screenshot of a div or an individual element. So if there's a lot going on your page, you don't need to sort of capture the whole screen. You can just take portions and capture those divs as screenshots.
We have quite a few more questions addressed here. I don't think we'll be able to
if anyone has questions, I can answer them via any other way.
So let me throw just one more at you. Do you know such a tool that is Java friendly, can be added as a library?
Yeah, so again, sound like a broken record. Applitools allows you to use pretty much all the common languages to use visual testing. The code I shared for C# is very similar to Java. So if you look at the examples, you could actually compute it yourself. It's very similar. And you can try that to see if it works for you. If it does, then see if it's worthwhile investing in a tool like Applitools. Perhaps the example I showed would be enough for you, depending on the use case, and then you'll save money. But it's one of those things you need to try and see if it works for you, really.
Great. Thanks a lot. Thanks a lot, Viv, for answering all these questions and for your very interesting talk. I hope you guys enjoyed it. I have approved more questions, so Viv, if you'd like to speak with any of our attendees, whether in the chat section, don't hesitate to reach out to him to ask even more. Thank you for attending this track. Now it's time to move on to the next one, to our next speaker. So see you soon.
Thank you. Thanks, Adam.
Hello. I'm really glad I can be here today, so thanks for the invitation, and let's start. Serverless. How to speed up tests over 300 times and achieve continuous feedback. Maybe just a few words about me. I'm Tomasz Konieczny. I currently work for Raw, one of the New York-based startups, as senior QA engineer. During my earlier career as a QA, I did very different things, but most of them were related to test automation. So test automation itself, test infrastructure, test architecture. I also worked for a year and a half as a DevOps engineer, so Docker, Kubernetes, AWS, Linux, and things like that. Today's presentation will be related to both of these areas, I mean test automation and test infrastructure. Okay, so let's start with a very basic question. Why do we execute end-to-end regression tests? Or maybe why do we execute regression tests in general? Because during the development of some new functionalities, it's possible that we'll introduce bugs to already finished ones. That's why we need regression tests. They are intended to detect these possible bugs. And why do we need high-level regression tests, like for example end-to-end tests? Because low-level tests can guarantee us that something is actually working correctly. I mean, if we have some low-level tests, it's great, but, well, there's a problem. I mean, if one of the low-level tests is red, it's quite obvious. I mean, something is wrong with the application or the test itself. But if all of these low-level tests are green, it only means that the tests are green. They can't guarantee us that something is working correctly. That's why we need high-level tests. Okay, but at the same time, there is like a really significant problem related to high-level tests. I mean, they are really slow. And in this case, if we are saying about regression tests, they are also repetitive. I mean, we have to repeat them again and again during the development process. But it's not only about QAs or development team's time that they have to spend on this repetitive execution. The second part of the problem is feedback time. I mean, it's really long. I mean, we have to wait for the results really long time to know if the application is still working correctly, or maybe there are some problems that we have to fix. So this second part may be even more important. Solution for that is automation. I mean, if we automate something that's repetitive, well, we can definitely save time on this repetitive execution. But the second thing is that we can really improve the feedback time here, because automated tests can be way faster than manual ones. Well, computers can click faster than humans. It is quite obvious. So it partially can solve our problem. So maybe instead of time, we should speak more about the execution speed, because basically that's our goal. I mean, to be able to execute tests as fast as possible. Because faster execution means faster feedback. If we'll be able to execute tests faster, then we will get feedback earlier in the development process. We'll be able to fix bugs earlier. It means that it will be easier, and at the same time, cost of fixing bugs will be way lower. So that's a great benefit of it. But it also means that, well, if we have faster feedback, we are able to deliver faster. I mean, if we can fix our bugs early in the development process, we have the better understanding of the application state, if it's working correctly. If we have this feedback earlier, then we can make decisions based on that, and we can also deliver faster. And that should be our goal. Well, it should be the goal of the software development in general. Okay, so that's why we automate tests. We can execute them way faster than manual ones, maybe even in a few minutes instead of even hours. If we have some automated build process, if we have some, for example, CI server, then we can include this automated test in the build pipeline. So we will get feedback even immediately after every repository push, after at every pull request. So, well, it's great. And if we have some proper test coverage, then we can start thinking about going with CD, continuous delivery, or even continuous deployment. Well, at least at the test part. Because if we have the test automated, we can get the feedback really fast. We can make decisions based on that. If we can raise the application, or we have to fix something else. So it's great, isn't it? Well, and then the problem appears. I mean, we develop our application and it becomes more and more complex, and it also means that we need more and more tests. And, well, it also means that the test set grows. So the execution time increases again, 10 minutes, 30 minutes, maybe even hours that we have to wait to get the results of our tests. So basically, we have the same problem again. I mean, the tests aren't fast anymore. Okay, how can we fix it? Let's assume that we have some, well, quite standard test set. Let's assume 500 Selenium tests, and execution of each of them takes about 20 seconds. So we need almost 3 hours to execute the whole set. Well, it's a really long time. Okay, how can we solve it this time? Because we already have it. Already have the test automated. Maybe we should think about test set redesign. Maybe we should introduce some small test sets that will be executed at, for example, pull request, and will execute the full set only in case of very specific events, like for example match to main branches, like master, for example. It will give us the fast feedback, at least very basic one, and at the same time, well, it will partially fix our problem. Maybe we should think about test pyramid. Maybe we can replace some of the high-level tests with low-level ones. I mean, low-level tests are way faster than high-level tests, so maybe we can implement something here. But what if we already have the test pyramid properly implemented, and we need every specific high-level test that we already have? Well, maybe another option, less frequent builds. So instead of running builds like every pull request, every repository push, we can run the tests like a few times a day. It will still give us faster feedback, well, in comparison to the manual tests, but is it really a solution for our problem? Okay, so maybe another option, more compute resources. Compute resources are becoming cheaper and cheaper, so maybe we can scale it up here. So instead of running one test at the same time, we can run like 4 instances for virtual machines that will run our tests at the same time. That will speed up the test execution like up to 4 times. So instead of 3 hours, it will be like maybe 45 minutes. Well, it's a bit faster, but well, it's not that fast. And at the same time, we have to think about cost. I mean, in real life, we won't have like one build at the same time. Sometimes we will have like 5 builds running at the same time, so we will need 20 instances, and sometimes we won't have any. So we will definitely need some infrastructure scaling, not waste the resources, because it will be quite expensive. So that's what I implemented like a few years ago. I used Kubernetes to create cluster, and it was auto-scaling, so well, it partially solved this problem, but another one appeared. I mean, it was a really complex solution, and the problem was that we lost the understanding of the infrastructure in the development team, because it was complex, and at the same time we had to maintain it, so, well, not the best solution. So my answer for all of these questions or possible like solutions is just no. I mean, these solutions aren't solutions at all. They are like very basic workarounds, and that's not something that will allow us to really solve this problem. For me, the real solution is cloud. I mean, we can do far more with cloud services, but it's really important to use cloud properly. So the services that are really suitable for some specific problem. So not some virtual machines again and again. We need something new here. we should use Cloud properly. So the goal that we want to achieve is definitely the parallel test execution, because that's the only way to really speed up the tests. I mean, I'm not saying like 4 or maybe even 8 instances running at the same time, because it's not that, like, it still won't be fast enough. I'm saying like hundreds instances running at the same time. So basically, the goal is to run every test at the same time. How can we achieve it? Well, I think that the easiest option is to use serverless services, because we don't want to think about this whole infrastructure. I mean, infrastructure scaling, management, maintenance. Well, we have our code, our tests in this case. We want to run them. Just it. So we want to deploy our code, trigger it somehow, and get the results. That's our goal. How can we achieve it easily? Used AWS Lambda. If you don't know it, it's the function services service in AWS Cloud. So basically, it allows us to deploy code in one of the supported languages like Python, Node, Java, and some other that are supported there. So we can deploy our code, trigger it, and we will get the results. It will scale automatically. We don't have to think about it. Okay, so what's great is that the initial concurrency of Lambda is from 500 to 3000 functions, depending on the region. So basically, we can deploy our code, trigger it like 500 times, and it will just give us the results. It's that easy. Okay, but what's really important in the case of Lambda is the functionality named Lambda layers, because we will have a lot of dependencies. So we will need, for example, browser to run the Selenium tests in Safari browser, like Chromium, for example, and we'll also have some other dependencies. And we don't want to deploy all of the dependencies along with our code every time that we change a single line of code, because, well, browser is quite heavy. So what the Lambda layers allows us to do is to separate code from the runtime part. Basically, it allows us to create custom runtime environments. So we'll have, for example, Lambda for Python, and we will add our dependencies there and create our custom runtime environment. Okay, in this case, I used also the serverless framework because it's a great tool, great implementation of infrastructure as code concept that allows us to create our infrastructure, not only Lambda function, but also other dependencies, like, for example, database or S3 bucket, anything we need. So that's what I used. Okay, let's start with the implementation part. Let's create our Lambda layers, our runtime part. I created the Lambda layers directory. Inside it, we'll have all of our libraries and dependencies. So Chrome directory, here we will have Chrome driver, because it's basically needed for Selenium to be able to communicate with the browser. And we also have our browser, so Chrome or Chromium. We will also have our other libraries, so that's why we have Selenium library. I just pip installed it to this directory, so all of the Selenium libraries and anything else that we need will be here. And we also have the serverless YAML file. Here we will have the description of our infrastructure. So service, Lambda Selenium layer, because that's our Lambda layer for, well, our test runner. Provider, these are the settings for the provider, in this case AWS, so name AWS. Runtime, that's the default runtime that we will use, in this case Python 3.7, and we will build this layer on top of it. Region, Europe West, timeout 30 seconds. It will be enough because every test lasts about 20 seconds, so 30 seconds will be enough. And also the definition of our layers, so Selenium and Chrome. Layers will be built based on Selenium and Chrome directories, and these layers will be compatible, compatible with runtimes, keyword, with Python 3.7 runtime. Okay, but we have one more problem. It was that easy like a year ago, because Chrome browser wasn't that heavy. But there are some limits. We can deploy it in that way currently, because we can upload up to 50 megs of, well, zipped sources, right, like directly, and we can build layers up to 250 megabytes. So that's, well, where we'll have to fit our browser and our libraries. And it was possible like a year ago when Chrome browser wasn't that heavy. We need some workaround nowadays. The idea is really simple. We can compress our Chrome binary before the deployment, so it will be lighter, and then we can decompress it during the runtime. Because we also have the TMP directory that's available for our Lambda function. We can put up to 512 megs there. So the idea is to decompress it to this directory. But it's really important to choose the compression algorithm wisely, because it has to be really fast in case of the decompression. Because we don't care how long it will take to compress it, because we will do it like during the deployment of the new browser, so maybe once a few weeks. But it's really important that it's fast in case of decompression, because we will have to decompress it every time we deploy or trigger our new function. So there are two algorithms that are great in my opinion. One of them is XZ or LZMA. The second one is Brotli, because the compression rate is really good in case of both of them, and they are really fast in case of decompression. Okay, in this case I used TarXZ or LZMA because it's, well, it has a better support in case of Python libraries. It's supported by Tarfile library. So before the execution of our test or our actual function code, we'll have to decompress our libraries. The code is really simple. Well, I even simplified it because we don't have some error handling here. It's really simplified. It's just a proof of concept. So extract dependency will just put a file name argument there, and it will decompress our file from op directory. That's the default directory where lambda layer is copied, to the TMP directory where we have available storage. It's that simple. We just have to execute this extract dependency for Chrome browser before the execution of the test. Okay, so now it's time for our function. Let's create our directory lambda test runner. That's where we will have all files related to the function, so handler.py, that's the Python file that will be executed, and also the serverless YAML file, that's the description of the infrastructure part. Let's start with the serverless YAML file. Here is the service keyword, lambda test runner, that's our service name. Then we have provider settings, so in this case again AWS, Python 3.7 runtime, region Europe West, and the new one, memory size. In this case 1 gig of RAM should be enough. We can increase it up to 3 gigs if it's needed. And also timeout 30 seconds, it should be fine again. And then this definition of the function, so the function named lambda runner, if we trigger it, it will trigger the handler file named handler and the lambda runner function that's inside of it. We also have the events that will trigger it and the layers. So in this case I used blackout formation IDs to simplify it a bit. We have to connect our layers here, so they will be available inside the lambda function. Okay, and now the implementation, the actual tests that will be executed. So in this case, standard import, Selenium, browser options, and also JSON, because we will have to create the responses. Then the definition of the our function, so lambda runner. There are two arguments here. We'll be able to pass, for example, test case ID here. And then we have the extract dependency method with the Chrome TarXZ parameters. So based on it, it will execute our browser binary to the TMP directory. Then the test result storage. Very simplified. This code is just a proof of concept to show you the general idea. So it's really simplified in some places. Then browser options, so binary location. We need the custom one here, so TMP Chromium. Then browser arguments. So we definitely need headless here because it will be executed in the headless environment. We also need to disable the shared mem, so disable def SHM usage, and also 2 arguments that are at least partially optional, so single process and no sandbox, because basically we don't need the sandbox here. It's a bit faster with the sandbox disabled. And then the driver settings, so in this case up the directory, because we don't have to compress the Chrome driver in this case. It will feed directly, but we have to define the custom directory for it. Then the actual test. I skipped this part because it would be just the standard Selenium, and everyone knows Selenium, I think. We can print anything to std out here, so it will be logged then. And then the response, just the test result, if that is passed or failed, and the status code. Now it's time for runner, so the code that will actually trigger our Lambda functions. So, imports Boto3 library, that's the official SDK from AWS for Python language. Argparse for parsing arguments, YAML JSON base64 for creating requests, parsing responses, and also concurrent features, threadful executor for triggering specific Lambda functions and threads. So then we have the arguments part. We have just 2 arguments, again just proof of concept, so it's really simplified here. So we have the verbose mode with more detailed logging, and we have the sequential mode that only disables the parallel mode. Okay, and next the test set part. So we will have all of our test cases in a file, and YAML in this case, so test case 1, 2, 3, etc. And it will just read the test cases that should be executed from this file. Then the data dictionary, so that's the execution state storage. So if the test is scheduled or executed, what's the result, what's the output of the tests, I mean the Selenium output. So we basically add this test state to every specific test case ID. So we can track the execution state based on that. Then the Boto3 client, so here is the configuration of our Lambda function, so Lambda, which region, AWS access keys, etc. Again, it's directly in the code because it's proof of concept. Then we have our invoke test method, so it has 1 argument. We can pass test case ID here, so it will execute just the specific test case ID. It will trigger Lambda function to execute just the specific test case ID. So basically, inside it we update our execution state for the specific test case ID, so that it's scheduled. Then we invoke our Lambda function, so our function name, invocation type, request response. That's the easiest one because you can make the request, it will wait for the response, and we will get the results directly. But later we'll have to replace it with event. I will show you why later. Payload, so here we can pass any arguments to our Lambda function. So in this case we'll pass the specific test case ID. So basically every specific Lambda function will contain the code for every test case ID, and it will just run the specific one based on this argument. So our handler. Then we have our test or our lambda executed. So we update our test case ID state to executed. We save the response, then we parse it. If the test passed, failed, we parse the results, etc. And then the code that will trigger the whole test set. So if the parallel mode is enabled, then it will use threadful executor with up to 500 threads in this case, again hard-coded to simplify it a bit. So it will run up to 500 threads to trigger this invoke test method 500 times with a different test case IDs. So then the invoke test method will trigger a specific lambda function, again with this parameter. Or if we have the sequential mode enabled, then it will just invoke the invoke test method one by one. Then some stats, very useful to see the results. So basically we iterate through all of these test states and check how many of the tests passed, how many of them failed, and also a very basic summary. So how many of the tests passed, how many of them failed. So let's run our test set. In this case, I used only 5 test cases because otherwise it won't be that readable. I mean, running 500 tests, well, it won't even fit here in the screen. So just 5 tests. I also used the time command to measure the execution time. So here you can see the execution logs. So the test cases from 1 to 5 were scheduled. So that the specific lambda function was triggered, then the test cases were executed. The order here is different because every function finished in slightly different time, so that's why the order isn't correct here. Then we have the report, so every specific test case passed in this case, and we have a very basic summary, how many of the tests passed, how many of the tests failed. In this case, all of them passed, and the execution times from the time command. So a real execution time is about 25 seconds. And also we have 2 other user and sys, so we can see here that it was executed fully on the lambda functions side. Our local code only triggered lambda functions. Okay, but earlier I told you that we have 500 tests, then I ran only 5 of them. So how long will it take to run whole test set, I mean 500 tests? Well, about 30 seconds. So we just reduced the execution time from almost 3 hours to about 30 seconds. Even if we include the deployment time, well, additional 10 seconds, it's still far better. Okay, but we just ran like 500 concurrent tests, 500 lambda functions or instances. What's the cost of it? Well, it's about 17 cents. So basically we can run it whenever we want, because if we compare it to the development cost, to the cost of the development team waiting for the results to make any decisions based on that, it's really low. Okay, but if we look from the other side, this proof of concept is really simple. I mean, it's only like a few hundred lines of code. So, well, it's surely simplified, but it works. Okay, but what are the limitations? The most important one will be related to API gateway timeout, because if we trigger our lambda function as a request response, then API gateway is used. And it means that we have the same limit. So in this case, the max execution time for our test is 30 seconds. So you have to fix this one. We can change the invocation type to event. In this case, we won't have this problem anymore, but we also won't be able to get the results directly. That's why we need some additional execution state storage. So the runner will create the specific test case ID item in the database, for example, DynamoDB that I used, and then after the execution, lambda function will just update the specific test case ID in the database, so we can track the results. So it will solve our problem. We'll be able to execute tests up to 15 minutes after that. Okay, how can we extend this proof of concept? Well, it's really dependent on what you need. In this case, I used a few other services that were really useful for me. So CloudWatch for low-level Lambda execution logs, and DynamoDB not only for result storage, but also for some additional build-related info that may be useful. I also used S3 Bucket for build artifacts, and also Runner is heavily extended, so there is fully custom scheduler, there is ramp-up period, there is third limiter that's really useful for some slower environments, so they have time to scale up. And in the end, I will just say one more thing. Cloud is really powerful, it can improve a lot of things, but it's really important to use it properly, to think out of the box how we can solve specific problems. And that would be all. Thanks. If you have any questions, you can write and I will try to answer.
Hello, everyone, and welcome back. I hope you enjoyed the last talk. The one that is coming is at least as great. I'm happy to have with me Adrian Bologno, who will talk to us about testing web accessibility. So, Adrian, thank you for being with us, and the floor is all yours.
Thank you for having me. I hope everyone is safe at home. So let me start my presentation and we can start. So today I'm going to talk about web accessibility and how to make sure that what we develop is accessible. Let me introduce myself again. My name is Adrian. I'm from Spain, from Madrid. I'm a team lead and a front-end developer at my company, and I'm a huge accessibility advocate. So, and you can find me almost everywhere under my surname. So let's talk about accessibility. But first, I usually get the question on what is this I11Y that we all see when we talk about accessibility. So this is the international acronym for accessibility, and this is because there is 11 letters between the A and the Y in the word accessibility. So I'm going to use a lot in this in the text and in the slides only the I11Y from now on. So why is so obvious in the real world that those four situations are completely wrong? So in the first one and in the second one, there is like very steep ramp. In the third one, there is a ramp, and at the end, there's stairs. And in the fourth one, there is a totally unusable ramp. So this is completely wrong. Let me show you a different example. So someone arrives in a wheelchair, and there is a button for accessibility, and then the door opens automatically. Very cool, but surprise, surprise, there is stairs after the door. So why is this so obvious in the real world for us? But when we move to the online world, accessibility is not an obvious topic. Web accessibility, I don't know if you ever heard about it, but it's mainly create tools and websites that do not exclude people from using their products or services. So everything is accessible and usable for people with disabilities. So let me show you an example of an online shop. So you go to Amazon or any e-commerce shop, and you want to know where your last purchases was. So maybe you don't know how to find it. So you call the support, and then they can tell you something like, oh, you need to click in the button in the top right corner. Or maybe you want to change your email address. So they can tell you something like, oh, you need to click in the button with the engine icon. But for blind people, there's no button with the engine icon, and there is no top right corner. We need to have this in mind when we create our e-commerces, our websites. Let me give you a couple of numbers first. In the world, last 2 years ago around, we were 7.6 billion people. And more than 1 billion people live with some form of vision impairment. It could be glasses, it could be 10%, it could be 30%, it could be color blindness, or it could be 100%, which is totally blind. I'm going to focus on visually impaired people during my talk. So I'm not going to talk about developing towards web accessibility. I have a different talk about this called How Does Your Website Sound Like? And you can find it in YouTube. But today I'm going to talk about testing web accessibility, how to make sure that what we develop is accessible. So automate tests are awesome. They are very cool, and they can free up your QA team for manual testing every part of your application. But it's not magic. They cannot automatically make your site accessible. You can find the issues. We cannot forget that only 20 to 50% of the issues can be automatically be detected. So we need to understand that these automate tests are part of a larger testing process where manual test is as important as automate tests. So I created a very small React application with 3 small components. The first one is a button. The second one is a fake button, which is an anchor link with the role button. Kids never do this. And the third one is an image. And in the entry point of the application, I put a lot of accessibility errors. And I want to see if using the tools that I want to show you, we can find those errors. When can we test for accessibility? I identified, in my experience, three different moments where we can test accessibility. The first one is testing during the development process. So we can test while we are developing a website. The second one, we tend to fall into the error to think that we are finished. Or maybe you can go to a new company and you inherit a code base. And the company said, look, we've never done any accessibility. So you need to test the whole thing. And the third one, as I mentioned before, is manual test. So we need to test as well our website manually. So let me talk about testing while we code during the development process. Since I am a React developer, I use some tools that they are very useful for React. I'm sure that the guys who develop in Angular or Vue or Ember or Svelte, for sure there are some others, but those are the ones that I use every day. So let me start with React Axe. Axe is a family of tools created by Deque, and they have different tools over the family. So one is a React library. So you need to install it as a developer dependency in your application, in your React application, and you need to call the exported function, being sure that you only import it or require in an environment which is not a production environment, because you don't want to expose those this information. What is React Axe doing? Well, when you run your application in the browser, in the console, in the developer console, you can see the issues that your website is having. So you can, as you can see in the screenshot, there is a browser open with the developer console open, and there are several issues displayed. They are as well grouped. So if you have, for example, 3 times the same error, for example, I have elements must have sufficient color contrast, they will group them. As well, they will display a severity level from critical to minor. The good thing, or I believe, for my opinion, the best thing of this tool is that they give you a link, a direct link to Deque University, which is the official documentation on how to fix those errors from Deque, obviously. So it's their official documentation, and you can learn more about the issue and how to fix it. As well, you can see where is the error. So in your HTML, what is the element that is violating this principle? And a bit of information about what is the error. For example, images must have alternate text, or form element must have labels. The second one are linters. We can use linters. For those who doesn't know what linter is, a linter is a library that you can use during development process, and it's basically a config file where you state the rules and you tell me that I'm wrong when I'm doing this. So basically, you are stating different rules, and then the code editor is shouting when you're doing something wrong. So if you use ESLint or TSLint, there are plugins for TSLint as well for TypeScript. But if you're using plain JavaScript, you can use the ESLint plugin for accessibility. So you need to include it in your ESLint JSON file. And in line number 12 in the screenshot, we have extends and then the recommended rules for those rules, right? For those linter rules. With this line, you'd be okay. I prefer to extend my rules because I want to have the freedom to specify what components I want to test and how. And as every linter, if you're doing something that you shouldn't be doing, then it's going to be this wavy underline, red wavy underline in your code. When you hover with your mouse, then the linter is going to tell you, in this case, that non-interactive elements with click handler must have at least one keyword listener, because I cannot have a diff with an on-click action. The same as the other rule that I'm breaking, which is static HTML elements with event handlers require a role. So during development process, you can fix those problems. And as well, you will be seeing those errors as well in the terminal when you run your application, npm run or yarn run, depending on the package that you use. The third one that I use, and probably is my favorite, is Jest. Jest, for those who doesn't know it, is a JavaScript library to create unit test, end-to-end test as well. I think the best use is to create a unit test. And we are back to the Axe family. Axe has a library for Jest, and you can install it as a developer dependency in your React application. Sorry, not your React application, but your JavaScript application if you're using Jest. And in the example that I'm showing in the screen, I created a very small test. I'm importing the whole app. And using the React DOM server, I'm transforming the whole app into a string. What can I do with this? I throw the string into the Axe engine. And then, of course, I'm expecting not to have, or to have no violations, right? Not to have violations. Whenever I run the test in the terminal, npm run test or yarn test, then I will see the same, pretty much the same information that I used to have with React Axe. So you're going to have where is the error in your HTML, what is the error that you're violating, or what is the principle that you're violating, and a direct link to the Equity University again to know more about the issue and how to fix it. And of course, you can use this in your continuous delivery pipeline, so you can avoid shipping non-accessible code to production in this case. So it's very good to automate those tests. But as I said before, sometimes you inherit a code base and you need to test the whole thing at once. So maybe you don't have access, you don't even have access to the code. So you cannot plug these libraries. So you need to test the whole DOM structure. So back to Axe family. Axe has a CLI, a terminal library use, right? So you can install it globally this time in your machine, and you can use it in the terminal, put in Axe and the URL that you want to test. So it's going to be the same result. It's going to run a headless Chrome, and it's going to test the URL. The information is going to be pretty much the same as the React Axe or the Jest Axe, since it's the same family of tools. What is the error? Where in the HTML is the error? The whole path of the HTML and the element that is causing this issue, and as we said before, the direct link to the Q University, so you can see about, you can learn more about the issue and how to fix it. Very similar tool is PI11Y. Again, you need to install it globally in your machine. It works exactly the same, PI11Y plus the URL that you want to test. And is I haven't read about it. I hope, or I think it's the same. It's going to be a headless browser. I don't know which one. And it's telling you pretty much the same example. So what is the error? In this case, it's giving you what is the principle of the WCAG, AA, AAA, that the elements is violating, the whole HTML path, and the exact element in your HTML who's violating the principle. In this case, you don't have a direct link to any documentation. It's your homework to and learn more about how to fix this error. Good thing as well, you can run this over localhost, so you don't need to run it over a server or any test environment that you have. You don't even need to do that. PA11Y as well, and maybe you can think about, oh, I have a lot of URLs to test, so I don't want to go one by one or wait until, so I don't need to write a script for that. So PA11Y has a CI and it's done already for you. And you can have a JSON config file where you can put an array of URLs that you want to test. And the first one is a plain URL, and the second one I give in some parameters, which is a timeout and a screen capture. So I want to take a screen capture. Maybe this is useful for reporting purposes, or maybe for a visually regression test. Maybe you want to test if the interface has changed. For whatever purposes, there's the option. And I think the best feature of this tool is that you can make actions, you can perform actions. So you can screen capture, you can navigate over the website, you can wait until an element with an ID or with a class is visible, you can click on it, you can perform actions. It's going to take longer. So if you execute PA11CI, it's going to take this array, it identifies that it's 3 URLs, it's going to run over them. The first one and the second one pretty fast. The second one, I'm taking 2 screen captures, I'm navigating, so it's taking a little bit longer. But at the end, what we have in the terminal is exactly the same log as we had before. So what is the error? What is the violation? Maybe, actually, they give you a recommendation. So if you have insufficient contracts, they say, oh, recommendation, change text color to white, FFF. And as well, it's giving you the exact HTML element in your code that is giving the violation. And we can see in the root of our folder, we can see the screen captures. So either you can use it again for reporting purposes, or you can extract these captures and throw it to a visually regression test system, right? Pipeline. Lighthouse. Lighthouse is a tool developed by Google and is included in every Google Chrome browser. It used to be called Audit under the developer tools. Now it's called Lighthouse, and it performs a lot of tests. But Lighthouse can be used as well from the terminal, so you can include it in your continuous delivery pipeline. It works pretty much the same as the other one, Lighthouse plus the URL that you want to test. In this case, I'm using the parameter or the flag --view because I want to fire a visual report after the test. And in this case, instead of a headless Chrome browser, it's going to be a full instance of Chrome. So if I run it, you will see that the Chrome launcher is launching, perfect. There's a full Chrome instance, and you will see how they perform a lot of tests. Performance, low internet, responsiveness, no CSS, accessibility, no JavaScript, every possible test. And it's gonna execute, or sorry, it's gonna generate an HTML report with some scores. And you can click in the accessibility or the performance or the best practices, SEO, progressive web app, and you can see what are the issues that your website is having. Pretty much the same as Axe or PA11Y is giving you what is the problem, where can you fix this problem. And in the link who says learn more, it's going to go to the official Google documentation about accessibility, so you can learn more about it and fix it. So for those tools, again, in my opinion, the main feature for Axe is clear for me. You have the direct link to Deku University, so you have the direct link to the documentation. In PA11Y, you don't have it. You have to do the homework, but you can use config options, so you can perform actions during in the website. And for Lighthouse, you can export this to a JSON file, and you can use it for reporting, for continuous delivery, continuous deployment purposes. Even for SEO, it's very useful to have a dashboard with all these those scores. So for Google are very important, those scores, the same as the Google Speed Index. But we said that only 20 to 50% of the issues can be automated, can be detected, with automate tests. So we need to make these manual tests as well. So I use Google Chrome in my daily work. So I have some extensions in the browser who I use to test accessibility manually. Again, back to the Axe family, back to Deque, and they created a Chrome extension. You can find it under the development tools. It's called Axe. And you can click in Analyze. You can perform a full analysis in the website, and it's going to give you exactly the same information that is giving you either in React Axe in the console or in the terminal with Jest or directly with Axe. So it's going to tell you what are the errors. They are grouped if you have several ones. They are going to give you the impact from critical to minor. They are going to give you the location, so the full path of the HTML, and the exact element. And you can have a direct link to Deque University, as we already said. Another very similar tool is ARC Toolkit. This tool is found as well under the development tools. It's called, I think, ARC. And you can click in test, right? Run tests. You can see the group of tests that they're going to run. In this case, I'm focusing on images. And you can see the images that doesn't have any alt. So you can click and directly go to your code. And even in the window is going to be highlighted. So you can see at one glance what are the images that doesn't have any alt text in this case. Accessibility insights. So in this case, more than telling you what you're doing wrong, I like one specific feature that the Accessibility Insight has, and is the tab order map. So tab ordering is very important because your users normally, right, the general audience is using a mouse to navigate through your website. But visually impaired people are going to use the tab key to navigate through your website. So your tab order needs to be consistent with the content of your website. So to be sure that this is happening, this tool is creating a tab map. So you click and you can keep tabbing, and it's going to create a map with numbers. So this is the tab order that someone who's using a tab key are going to see. Like this, you can see if this is relevant for the content of your website. If the jumps are correct in the correct order, you need to change the HTML DOM structure, or maybe you need to use the tab index at some point to customize a bit this order. So I think it's a very useful extension to test this. Wave, which is the web accessibility evaluation tool, it was updated some months ago, and I think it's the most complete one. So you can find it under your extension bar, and once you click, it's performing the whole test. And you can see the missing alt text in the images. You can see a map of headings, very important for SEO, H1, H2, H3. You can see the differences in the contrast, so AA or AAA. So you can see you have some problems with some buttons. I mean, orange and white is not the best. You can deactivate the whole styles, the whole CSS. So you can see if the HTML is well structured. Or you can dig into the code if you feel that you want to take a look directly to the HTML code. So I think it's a very complete tool to test accessibility in the browser, and it's giving you a lot of insights about what you're doing in your website. But not only testing is important, I think a huge part of testing is to put yourself in the skin of the user. In this case, I'm showing you a simulator. So it's called No Coffee. And you can see, and emphasize see, how someone with visual impairment will see your website. So blurry, for example, someone that take out their glasses or forgot their glasses will see your website like this. Maybe you need to change the typography or the size of your fonts, or cloudiness or snow, or maybe flutter, as well for color blindness or protanopia, or not even colors. So you can see that you cannot rely only on colors when you're displaying a message. As well on visually impairment like glaucoma, so central and peripheral vision, or maybe spots or floaters. You can customize the amount and the strength of the floaters. So I think it's a very valid simulation or simulator to put yourself in the skin on your audience. When you want to develop a website, you want to reach as much people as possible. And at the beginning, I said that more than 1 billion people in the world has any visual impairment. Any visual impairment. So those people are your audience as well. So you need to be sure that your website is usable and accessible for those. So those are the tools that I usually use every day in my development process. There are more. For example, I normally use now another extension called Funkify, and it's another simulator. So you have personas, and you can simulate one persona is someone who is colorblind. The other one is someone with dyslexia, someone with floaters. So you can customize those personas for your UX research. Are very interesting. There are more, as I said. Now it's up to you to take a look at them and see if they're valid for you, or you can discover new ones. If you discover new ones, please send me a tweet. I would love to test them. I would love to use them. The React application that I created is hosted in my GitHub. So you can take a look and play around and fork it or clone it, or if you want to add anything, just please create a pull request. It's an open source repository for sure. The slides of this talk and any other talk that I gave are in my speaker.com profile. If you don't like to see the slides again, or you don't like to rewatch any talk and you prefer to read, I wrote 3 parts of articles about the content of this presentation. So you can copy and paste the code and play around with it. I would love to take advantage of the talk and recommend a accessibility course. It is for free and is officially created by the W3C, which is the community that generates the HTML and CSS standards for our browsers. So they extended the period until September. So I encourage you to take a look. It's not technical, so it's not only for technical people. It's an introduction to web accessibility, and is a very, very well done course. I want to leave with a couple of sentences because I think they are quite important, and it's something that when we develop, it's not just about disabled users being able to access your website, but it's about everyone being able to access your website. Because you don't have to make your website accessible only for these people. You can be yourself situational disabled. So maybe you forgot your glasses at home if you use them. Or maybe you don't have your mouse with you, or maybe you're a gamer and you don't use a mouse, or maybe you have kids and you have your kid in one hand and you need to use your computer with just one hand, so you need to navigate through a website using the tab key. Or maybe, for example, around 3 months ago, I dropped my computer, so my screen was completely black. So I needed to do some actions, and I didn't have a second screen. So I needed to listen to the websites using a screen reader. So you, in these occasions, in these situations, you figure out how disabled are, how inaccessible are websites that you thought that everyone can use. So especially yours, you need to take care about this one. Why I say that? Because accessibility is not a feature, because disability is not an option. We need to treat accessibility as a one step more of our development process. The same as we do with UX review, the same as we do with writing unit tests for every functionality that we create, the same as we write end-to-end and integration tests for API calls, the same as we have specifications in the tickets. If you use Jira or any ticketing system, you count with your PM writing specifications. So accessibility is one part of our development process. It doesn't cost extra money. So W3C, HTML already thought about everything. It is not taking, it doesn't cost any money on time, because if you have an image of a dog playing with a ball, it takes you exactly 10 seconds to write an alt equal colon as a quotes, dog playing with a ball quotes. Or you have a button with an X to close a window, or a modal dialog, and it doesn't take you any long to write an ARIA label that says close the current window or close the current modal. If you have a link with a telephone number, for screen readers will only be a number. But if you take 10 seconds to write an ARIA label that says call the support team, those things take not much time. The other thing as well is accessibility is not only a responsibility of the developers or the testers. It needs to be a whole team responsibility. Your PM needs to be involved. Your UX designer needs to be involved. They need to think that they need to underline their links. They need to do it in the best possible way for the corporate image. You need to get involved with your PM, with your CTO, with your CEO. Everyone needs to share the same values here. As well, I think we developers normally and often create inaccessible websites because we don't know how to develop. So education is the base of this one. If you're developers, please learn HTML. Very good. It's the base of everything. And sometimes the problems are a base of education. So if you know that you need to use a button when you want a element that is clickable, is focusable, and performs an action, use a button. They don't fake a div with a roll button. And if you want to click in something and go to a different page, then it's a link, and it has to have an href, and it has to have the correct elements. So learning HTML, learning the accessible HTML is very important, because that will help a lot to testers or to any test that you pass later. So that's pretty much.
Thanks a lot, Adrian, for your great talk. Quite inspirational to see some of these good practices and recommendations that we have for putting accessibility also as a thing to look after when we develop. We have some questions for you, and I'd like to address them to use the time that we have left. First question: is it possible for the tools to find an issue where there isn't one? Like if you have an empty alt text to define that the image is only decorative.
Okay, very good question, because I have almost all the time talking about this specific topic, which is do we need the human interaction here, or do we rely only in the tools? So again, I have a good friend who is a blind developer, and he always tells me the same. If you put an image and you put an porn image, someone naked, and you put an alt, a kitty cat playing with a ball, for me, it's a kitty cat with a ball. So you can trick me. The same as the alt, empty alt, if the image is decorative. These tools are only telling you the standards. So the standard in HTML is that every image must have an alt property. We can, and I think we are not ready yet, but we have artificial intelligence to identify the image and see if you are explaining, because at the end the alt is how will you explain an image to someone who cannot see. So those tests, those tools can only tell you the standard HTML that W3C and the accessibility rules are defined. So again, only if the alt is present, but not what is the content and if the image is decorative or not. This one you need a bit of artificial intelligence or a bit of smarter way to figure that out.
Thank you. One more question. Another one goes like this. Different tools are returning different accessibility issues on the same web page. Is there a tool that you would recommend that catches all, most relevant issues?
Good question. If I need to recommend you, I will recommend you use more than one. For the sake, it's not difficult to plug more tools, and you will have, definitely, I agree with this person. Sometimes some tools give different results based on, because they set their standards differently. For me, I think one of the most complete one is Axe, or the whole Axe family. So the Axe engine, you have React Axe for React, you have Jest for Jest unit test, you have Axe directly in the terminal, you have the Axe Chrome extension, and since a month ago or 3 weeks ago, you have Axe in the GitHub Actions for commits and pull requests. So if you use GitHub, you can pass this automatically in GitHub. So it is a big community. It is well maintained. It is continuously maintained, and I think it's a good tool to start with. PA11Y is very, very good. Lighthouse is based on the standards that Google sets, and I think it's good. I prefer to use several ones.
Mm-hmm. And as a follow-up to these questions, do you have somewhere the list of these tools?
A list of the tools?
Yes.
The tools that I showed you yesterday now is in my blog, but I can create a list of tools. That's a good blog post idea. A list of tools that I recommend for different specific issues. So
excellent.
Thank you for the idea.
Excellent. One more question we have.
Yes.
Would it be good for people with disabilities to also test the applications?
Yes.
And as a guidance for more things that the tools do not support yet.
Absolutely. Actually, so another thing that I don't mention in my talk is, apart from the Chrome extensions, which is the manual test, I do a different manual test, which is I normally have the screen reader on in my headphone. So I normally listen to the website as well. But I use a Mac. So every operating system has a screen reader that comes with the operating system. Mac has VoiceOver, Windows has Narrator, and Linux has Orca. based on the experience of my friend who's blind, no blind people uses the screen readers of the operating system. They use normally NVIDIA, NVDA, or Jaw, which is very expensive, and NVIDIA is only for Windows. I think it's extremely valuable, and I think even better of the test tools to have someone who is blind to use your application. If you can do this, please do. Maybe talk to your UX researcher in your company. I'm trying to do it in my company, but in my case, we need to set a legal process to have this with a official institution of disabled people in Austria, in this case. But it's super cool to have usability tests with real users, because they will tell you that, yes, the contrast ratio for someone who is partially colorblind is perfect, but you are not giving me the context that I needed. So if there is a button with an ARIA label and the ARIA label is wrong, actually there is a non-written ARIA rule, which is no ARIA is better than wrong ARIA. So it's better than don't confuse people with wrongly and confusing ARIA than don't use it. So I think it's very useful to use real users if you have the opportunity.
Excellent, thank you. If you have more questions, don't hesitate to write them down. We have a couple of more minutes for this. So let's just wait a bit to see if people ask more questions.
Sure. And if you want to ask me any question later, or you are too shy to do it in the chat, then please write me a private message on Twitter or anywhere, and I will make my best to answer your questions.
Right. It would seem that we don't have any more questions. Thanks a lot for attending. Thanks a lot for the great talk, Adrian.
Thank you.
Thank you for coming to DevTalks as a speaker. For the attendance, for the audience, we will jump into the next session shortly. So join us for the last session of the very successful day at QA and testing track. Have a great day. Hello and welcome to the last talk of the day. We apologize for starting it a little late. We had some slight technical issues, but I'm happy that we are here with Dave Aronson, software development consultant, who will talk to us about how to kill all the mutants, a little bit more on intro into mutation testing. Dave, the stage is all yours. I'm going to put myself on mute.
Okay, now let's see if we can do this right again. Seeing the right slide? Okay.
Yes.
There we go. Bună ziua, București! Mă numesc Dave Aronson și eu sunt aici să vă spun cum să mori mutanți, dar o voi face in engleză. Mainly because you've just heard roughly half the Romanian I speak. Now let's start with the basics. What are mutants anyway? They're something out of mutation testing. So what on infinite Earths is that? In our universe, that of software development, not comic books, it's a software testing technique. Big surprise there. You might look at that name and think, well, it's obviously about testing the mutations used in genetic algorithms. But no, it's about testing our code and our unit test suite by using mutations. Its most unusual benefit is to help ensure that our unit tests are strict by finding the gaps in our test suites that let our code get away with unwanted behavior. Once we find gaps, we can improve our tests to close them. Lack of strictness comes mainly from lack of tests, poorly written tests, or poorly maintained tests, such as ones that didn't keep pace with changes in the code. Speaking of which, mutation testing can also help ensure that our code is meaningful, meaning that any change to the code will produce a noticeable change in its behavior. Lack of meaning comes mainly from code being unreachable, redundant with other code, or otherwise not having any real effect. Once we find meaningless code, we can make it meaningful if that fits our intent, or just remove it. Mutation testing puts these two together by checking that changing the code does indeed change its behavior, and that the unit test suite does indeed notice that change and fail. Not all tests have to fail, but each change should make at least one test fail. That's the positive side, but there are some drawbacks. As Fred Brooks told us back in '86, there's no silver bullet. Besides, those are for taking care of werewolves, not mutants. The first drawback is that it's rather hard labor for the CPU, and therefore usually rather slow. We certainly won't want to mutation test our whole code base on every save. Maybe over a lunch break for a smallish system, or overnight for a larger one, maybe even a weekend. Fortunately, most tools include an incremental mode, so that we can test only what has changed since the last mutation testing run, or perhaps the last commit. That maybe we can do on each save for a very small system, or at least over a shorter break for the rest. Also, its CPU-intensive nature can really run up our bills on cloud platforms such as AWS or Azure, whatever. Another drawback is that mutation testing is not at all a beginner-friendly technique. It tells us that some change to the code made no difference to the test results. But what does that even mean? It takes a lot of interpretation to figure out what a mutant is trying to tell us. Their accent is very strange, and they're almost as incoherent as zombies, but with a much larger vocabulary, so they're not always on about brains. They're usually trying to tell us that our code is meaningless, or our tests are lax, or both. but it can be very hard to figure out how. Even worse, sometimes it's a false alarm because the mutation didn't make a test fail, but it didn't make any real difference in the first place. It can still take quite a lot of time and effort to figure that out. Even if a mutation does make a difference, there is normally quite a lot of code that we shouldn't bother to test. For instance, if we have a debugging log message that says the value of x is, and then the value of x, that constant part will get mutated, but we don't really care. Fortunately, most tools have ways to say, don't bother mutating this line, or even this whole function. But that's usually with comments, which can clutter up the code and make it less readable. Now that we've seen the pros and cons, how does mutation testing work? It mutates copies of our code, hence the name. It does this to create test failures, also known as faults. So mutation testing is a fault-based testing technique. This means it is related to something you might already be familiar with, Chaos Monkey from Netflix. Just like Chaos Monkey helps Netflix discover flaws in their error recovery, mutation testing helps us discover flaws in our tests and our code. But the way mutation testing does it is sort of upside down from what Chaos Monkey does. Chaos Monkey is best known for injecting faults, such as dropped connections, into Netflix's production network. If all still goes well, in the sense that Netflix's customers don't notice and their metrics are still good, then that doesn't mean that all is well. That means that there is a problem. Remember, each change to our code should make at least one test fail. So how does it do all that? Let's peel back one layer of the onion and look at it from a high-level view. First, our chosen tool breaks our code apart into pieces to test. Usually, these are our functions. Then, for each function, it tries to find that function's tests. If the tool can't find any tests, most will simply skip this function. Better yet, most of those will warn us, so we know we should go add or annotate some tests. More on that later. Assuming we aren't skipping this function, next the tool will make the mutants. To do that, it looks closely at this function to see how it can be changed. For each tiny little way this function can be changed, the tool makes one mutant with that one tiny little change. Once our tool is done creating all the mutants it can for a given function, it iterates over the list. And now we get to the heart of the concept. For each mutant derived from a given function, the tool runs the function's unit tests, but it runs them using the current mutant in place of the original function. If any test fails, this is called killing the mutant, which may sound bad, but it's a good thing. It means that our code is meaningful enough that the tiny change that the tool made to create this mutant actually made a noticeable difference in the function's behavior. It also means that our tests are strict enough that at least one test noticed that difference and failed. Then the tool will stop running tests against that mutant and move on to the next one. Once this one has made one test fail, we don't care how many more it could make fail. Like so much in computers, we only care about ones and zeros. If the mutant doesn't make any tests fail, it is said to have survived. As a quick detour, some people object to this violent communication. In the comic books, mutants are often metaphors for marginalized groups, and the tech industry is starting to become more sensitive to such issues. So I'm trying to come up with some nicer terminology. So far, I'm leaning toward the term covering the mutant, which makes a good analogy to normal test coverage. Each mutant should be covered by one failing test. Unfortunately, that term is already used to mean that the mutated code is run by at least one test, much like the normal concept of test coverage. So I'd like to replace that with saying that the mutant is exercised, but it's rather an uphill battle trying to change terminology. Anyway, back to the normal stream of this presentation. Whatever we call it when a mutant does or doesn't make any unit tests fail, it should make at least one test fail, so when it doesn't, that's bad. It means that the mutant has the superpower of mimicry, skilled enough to fool our tests. This usually means that our code is meaningless, or our tests are lax, or both. And now it's up to us to figure out how. Now let's peel back another layer and look at the technical details of how this works. First, our tool parses our code, usually into an abstract syntax tree. I know those boxes may be too small to read well, but we don't need to understand this one in detail. After our tool creates an AST out of our whole system's code, then it traverses the tree, looking for subtrees, or branches, if you will, that represent our functions. After finding them, it handles them as I described it before, starting with looking for each one's tests. But how does it do that? That usually relies mainly on us developers, either annotating our tests or following some naming convention. This is often supplemented and sometimes even replaced by the tool looking at what unit tests call what functions. However, that can get tricky if the function is not directly called from the test. In that case, it usually involves looking at the test coverage data or some such gathered information from other steps. After the tool has found the function's tests, then assuming it's not going to skip this function for lack of tests or whatever reason, it makes the mutants. To make mutants from an AST subtree, it traverses that subtree just like it did to the whole thing. But instead of looking for smaller subtrees it can extract, now it looks for nodes where it can change something. Each time it finds one, then for each way it can change that node, it makes a fresh copy of the function's AST subtree with that one node changed in that one way. For instance, suppose our tool has started traversing the AST I showed earlier and has gotten down to this not equal comparison following those arrows. For each way it could change that node, it would make a fresh copy of this whole subtree with only that node changed in only that way. After it's done making as many mutants as it can from that node, it would continue traversing the subtree and do likewise to all further nodes, and it will have already done so to that while node that is above the comparison. So what kind of changes can it make? There are quite a lot. It could change a mathematical, logical, or bitwise operator from one to another. In languages and situations where we can do so, it could even substitute an operator from a different category. For instance, in many languages, we can treat anything as Booleans. So x times y could become, for instance, x and y, or x or y. When the order of operands matters, such as in subtraction, division, or exponentiation, it could swap them. It could change a comparison from one to another. It could insert or remove a mathematical, logical, or bitwise negation. It can remove entire lines of code. It can remove a condition or a loop control, and we'll see one of those later. It could scramble or truncate argument lists of function calls or function declarations. It could replace a function's entire contents with a constant or any of the arguments, or raising an error, or nothing at all if the language permits. It could change a constant or variable or expression or function call to some other value. It could even change it to something of an entirely different and incompatible type, such as changing a number into a, if I may quote Smeagol, string or nothing. There are many, many more, but I trust you get the idea. From here on, there are no more low-level details I want to add, so let's finally walk through some examples. We'll start with an easy one. Suppose we have a function like so. Think about what a mutant made from this might return, since that's what our unit test would probably be looking at, since this has no side effects. Mainly, it could return results such as any of these expressions or constants, and many more, but I had to stop somewhere. Now, suppose we had only one test, like so. This is a rather poor test, but even so, most of those mutants would get killed by this test, the ones shown here in crossed out green. The ones returning constants are very unlikely to match. Subtracting gets us 0, dividing gets us 1, returning either argument alone gets us 2, and the error conditions will at least make the test not pass. But addition, multiplication, and exponentiation in the reverse order all get us the correct answer. These mutations will therefore not be killed by this test. When we run our tool, it gives us a report that looks roughly like this. The exact words, format, amount of context, and so forth will depend on exactly which tool we use, but the information should be pretty much the same. And that is that if we change the function called power, which is in file demo.rb starting at line 42, in any of 4 different ways, then all of its unit tests would still pass. And those 4 ways are to change line 42 to swap the arguments, or to change line 43 to change the exponentiation into addition or multiplication, or to change line 43 to swap the operands. So what is this set of surviving mutants trying to tell us? A good start to figuring that out is to ask ourselves, how are these mutants surviving? The usual answer is that they give the same result as the original function, or same side effects if that's what your tests are looking at. To determine how that happens, we can take a closer look at one mutation and a test it passes. Let's start with the plus mutant. Looking at the change together with our test makes it much clearer that this one survives because 2 plus 2 equals 2 to the 2nd power. To kill this mutant, we need to make at least one test use arguments such that x to the y is different from x plus y. For instance, we could add a test or change our existing test to assert that 2 to the 4th power is 16. All the mutants that our original test killed, this would still kill. 2 plus 4 is 6, not 16, so this kills the plus mutant just fine. For that matter, 2 times 4 is 8, which is also not 16, so this kills the times mutant as well. The argument swapping mutants still survive because 4 squared happens to equal 2 to the 4th power. But we can kill them separately. There's no need to do it all at once and be some kind of superhero about it. Again, we can either add a test or adjust our existing test in some way such as this, asserting that 2 to the 3rd power is 8. 3 squared is 9, so this kills the argument swapping mutants. 2 plus 3 is 5, and 2 times 3 is 6. Both of those are not 8, so the plus and times mutants stay dead, and we don't get any zombie mutants wandering around. With these inputs, the correct operation is the only simple common one that yields the correct answer. This isn't the only solution, though. We could have used 2 to the 5th, 3 squared, 3 to the 5th, vice versa, and many, many more. There are lots of ways to skin that flurkin. This may make mutation testing sound simple, but this is a downright trivial example, so we could easily think up arguments to make all the mutants behave differently from the original code. So let's look at a more complex example. Suppose we have a function to send a message like so. This function sendMessage uses a loop that sends as much as send bytes can handle in one chunk, over and over, picking up where it left off until the message is all sent. This is a very common pattern. A mutation testing tool could make lots and lots of mutants from this, but one of particular interest would be this, removing those lines with the minus signs, an example of removing a loop control. Now, suppose that this mutant survives our test suite, consisting mainly of this. There is a bit more that I'm not going to show you quite yet, dealing with setting the size and creating the message. Even without seeing that code, what does the survival of that non-looping mutant tell us? If a mutant that only goes through the while loop once acts the same as our normal code as far as our tests can tell, that means that our tests are only making our code go through that while loop once. So what does that mean? You'll find that interpreting mutants involves a lot of asking, so what does that mean? Often recursively. In this case, it means we're not testing sending a message larger than send bytes can handle in one chunk. The most likely cause of that is that we simply didn't test with a big enough message. For instance, suppose our maximum chunk size, what send bytes can handle in one chunk, is 10,000 bytes as shown in the network module. For whatever reason, we're only testing with a tiny little 3-byte message as shown in the test, or possibly 4 bytes if you have a null terminator in that language. The obvious fix is to use a message larger than our maximum chunk size. We can easily construct one as shown here. We just take the size, add 1, and construct that bigger message. But perhaps the fault is not in our tests, but in our code. Perhaps we did test with the largest permissible message out of a predefined set of messages, or at least message sizes. For instance, here we have small and large message sizes, and we test with a large, but the mutant survives. So we're still sending the whole message in one chunk. What could be wrong with that? What is the mutant trying to tell us now? It's trying to tell us that a version of send message with the looping removed will do the job just fine. If we remove the loop control and then everything we only needed to support the looping, then it boils down to this. And now the real message is pretty clear. The entire send message function may well be redundant, so we can just use send bytes directly. Now, in real world code, it might not be redundant because there may be some logging or error handling and so forth that we need to do there, but at the very least, the looping was redundant. Fortunately, when it's this kind of problem with unreachable or redundant code, the solution is clear and easy. Just chop out the extra junk that the mutant doesn't have. This will also make our code more maintainable by getting rid of useless junk. Now that we've seen a few different examples of spotting bad tests and redundant code, I'd like to address a few frequently asked questions. First, this all sounds pretty bizarre, deliberately making tests fail to prove that the code works. Where did this bizarro idea come from anyway? Mutation testing has a surprisingly long history, at least in the context of computers. It was first proposed in 1971 in Richard Lipton's term paper, Fault Diagnosis of Computer Programs. The first tool didn't appear until 9 years later, in 1980, as part of Timothy Budd's PhD work. Even so, it was not practical for most people until fairly recently, maybe the past couple decades, with advances in CPU speed, multi-core CPUs, larger and cheaper memory, and so on. That leads us to the next question. Why is it so CPU intensive? To answer that, let's do some basic math. Suppose our functions have, on average, about 10 lines each, and each line has about 5 places where it can be changed to any of about 20 alternatives. That works out to about 1,000 mutants for each function. And for each one, we'll have to run somewhere between 1 unit test, if we're lucky and kill it on the first try, and all of the function's unit tests if we kill it on the last try or it survives. suppose we wind up running just 1/10 of the tests for each mutant. Since we start with 1,000 mutants, that's still 100 times the test runs for that function as our normal unit testing. If our unit test suite normally takes a zippy 10 seconds, mutation testing will take about 1,000 seconds, which is almost 17 minutes. But there is some good news. Over the past decade or so, there has been a lot of research on trimming down the number of mutants, mainly by weeding out ones that are semantically equivalent to the original code, redundant with other mutants, or trivial in various ways, such as creating an obvious error condition. Such things have reduced the mutant horde by up to about 2/3. But even with that rare level of success, it's still no silver bullet, as this takes lots of CPU time itself, and the remaining mutants are still quite a lot. The last common question is, when making each mutant, why change it in only one way? There are multiple reasons. First, it helps us poor humans focus. It's much easier to tell what a surviving mutant is trying to say if we're only talking about one thing at a time. You can think of it like the single responsibility principle. Another reason is that multiple changes might balance each other out, leading to more false alarms. For instance, that first simple example with its argument swapping mutants could have such a situation. If one mutant had both of these mutations, the first would swap the arguments and the other would swap them right back for no net effect. Last, allowing multiple mutations would create a combinatorial explosion of mutants, with the tool making many, many times more mutants per function, which would make it even more CPU intensive. I'll spare you the math, but with our earlier code side assumptions, even if we manage to weed the mutants down by 2/3 at each step, with one mutation per mutant, we'd have 333 mutants per function. And 1/3, but I'm rounding. With 2, we'd already have almost 110,000. And with 3, we'd still have over 35 million. Never mind actually running the tests, just creating the mutants would get to be quite a heavy workload. But we can avoid this huge workload and the increased false alarms and the lack of focus if we just limit it to one mutation per mutant. To summarize at last, mutation testing is a powerful technique to ensure that our code is meaningful and our tests are strict. It's easy to get started with in terms of setting up most of the tools and annotating our tests if needed, which may be tedious, but at least it's easy. However, it's not so easy to interpret the results, nor is it easy on the CPU. Even if these drawbacks might mean it's not a good fit for our particular current projects, though, I still think it's just a really cool idea in a geeky kind of way. For those of you who do better staring at code than hearing me talk about it, here's some pseudocode showing how mutation testing works from a very high-level view. I believe this presentation will be put online eventually, so seeing as we're tight on time, we won't pause here to read it through very thoroughly. And if you'd like to try mutation testing for yourself, here is a list of some popular tools for some popular languages and platforms, and some others. I doubt many of you are doing Fortran 77 these days. Again, we won't be pausing here. Just know that many of these are outdated. I don't know or follow quite all of these languages and platforms. The ones I know are outdated are crossed out. Before we get to Q&A, I'd like to give a shout out to TopTal, a consulting network I'm in, whose Speakers Network helped me prepare and practice this presentation. Please use that referral link if you want to hire or join us. That tag on the end tells them it was from me. That's also where the QR code goes. Also, many thanks to Marcus Sherp, who created Mutant, the main tool I've actually used, which is for Ruby, and he's been very willing to answer my ignorant questions and critique this presentation. And now it's your turn. And if you think of any questions later, there's my contact information up there.
Thanks, Dave. Thanks for the talk. Very, very interesting. I'm happy to see that quite a lot of cool and interesting talks were on the QA and testing track. We have one question. The mutation testing sounds like exhaustive testing since it enforces a unit test for each possible mutation. Can it be implemented for a very big software product?
Well, the bigger the software product, the more functions and therefore the more mutants. And yes, it's possible, but it will probably take rather a long time. That's one of those cases where I would recommend doing a first pass over a weekend or longer, or perhaps don't even bother with code that already exists, but just run mutation testing on what you have just changed, like since the last commit. In particular, that tool mutant I was talking about for Ruby has an incremental mode that goes back to the previous commit.
Mm-hmm. Thanks a lot. Thanks a lot. It was great having this talk. I'd like to ask you now, Dave, to stop sharing your screen because it's time for me to share mine. We have come to the end of our track, but it's not over yet, as we do have some very cool surprises for you. I'd like to first thank every one of you who attended the session today. I do hope that you found them interesting, and I do hope that you found this digital event as a success. Now what we have from our sponsor is 3 raffles that we will be doing live. And first of all is around a treasure hunt, and for these raffles we would like to thank the main sponsor for the QA and testing track, London Stock Exchange. The first one has as a prize an Xbox, and we will draw from let's see, so starting from 2 to 119, so 180 participants, and I will do this, well, 1 second, because I didn't share the right screen. Give me 1 second for me to share my full screen. Okay, so we go from 1 to 118. I hope you guys can see my screen now as I will hit generate, and we have 69. So we will put here, that's the number, the code 69, won the Xbox. Congratulations. I don't know who it is at the moment. But the organizers will reach out to you for this. The second one is around the quiz, and here we have as prize an Apple HomePod. We started 2 again, and now we moved to, there were quite a few more here, 269, so we have 268 to draw from. 268. So let's see, what do we have? We have 185. So 185. And for the last one, for the QA and testing track, we have 4 codes for a pack of VR glasses. So let's do again 1 to 4. And we get 4. Congratulations to all the winners. Thanks again for staying with us for the full day on the stage. It was, I hope you found it as interesting as I did. Looking forward for our next event. Let me thank again to all the to all the people that made this possible in such a short time. Have a great day and a great weekend.